Hello everyone, how is my audio doing? Audio is visible? Perfect. Glad you can see me speaking and hear my screen. Um all right, let's get started then. Um to answer the question in chat, I don't really use Codeforces. You can see that my Codeforces history is pretty dead. Last time I did a contest was in 2021. Also, it seems like Tourist isn't first on Codeforces globally anymore, which is very surprising to me. Sorry, I can't really live caption my own stream. Okay. Well, let's get on with the first part of the stream. Like I said in the announcement, first thing I'm going to do is draw the giveaway entries. Can everyone see my screen fine, or should I make the text larger? Slightly larger? Okay. Um, hmm. That should be okay. Hopefully. Okay. So these are the giveaway entries I've pulled from YouTube. I spent like an hour on it last night because YouTube really likes not letting me see all of my comments. So it took me quite a while to make sure I'd gotten them all. So of course I could just chuck this into like random.org or whatever, but you know, this is a coding stream. Why would I do it any way other than, coding a solution to it? So let's make this the first problem we do. So the input will be a list of names, each represented in a markdown list format, separated by new lines, and we need to print out the 6 giveaway winners. 1 will get lifetime with code crafters, 2 will get 3 months, and 3 will get 1 month. So, let me just briefly go over my setup because I've received this question a couple of times in my comments, and I figure it makes sense to explain exactly what I'm doing here. So I have a bunch of scripts set up here that give me a couple of utilities. So for example, what these are basically doing is it brings me to my Advent of Code folder when I run these commands, and it runs the solution piping in the input file. And this one runs the solution on the main input, this one runs the solution on the test input. And what this is doing is it's basically just turning the test output blue. So this is the ANSI code for turning something blue. This is the ANSI code for resetting the colors. And when I run the AOC command that you see, it's really just running the test code and then the main code, or rather the test input file and then the main input file. I also have some JavaScript utilities that I don't use because I don't use JavaScript for AOC. As for this function that you haven't seen me use on stream, but is what I use to get my inputs really quickly, basically what I'm doing here is I'm just curling the input directly from the Advent of Code website and putting it into in.txt. So that's how I'm able to load it really quickly. If I do not provide any date, then it will automatically find the year and day of the current time. This only works during December. And then if I specify, I can, for example, AOC load 2024-3, for example. Now, unfortunately, I forgot to install WSL, so I can't use this script right now, so I'll just be doing it in PowerShell. And so the way I'm going to do it is I'm just going to cat the input file directly into the solution. It's going to roughly do the same thing. So a couple of people have asked exactly what this means, because you'll see this a lot in basically all of my programs. Oh, No, I'm not using Linux. I'm straight up just using standard issue Windows 11. I know that's probably like sacrilegious, but you know, I'm mostly doing it for the because it's less likely to mess up things on the stream. Okay. So open is the Python function for opening a file. Typically what you might see is something like this, open in.txt. And this would work fine in our use case anyway. So this would allow me to avoid the cat in.txt part. But there are also 3 special IO streams. 0 is the standard input stream. 1 is the standard output stream, and 2 is the standard error stream. If I open 0, then that lets me read everything that's piped into standard input. So for example, if I run this, then enter some input and then hit Control D. I don't know how you signal an EOF in PowerShell. This is a problem. Well, guess we're doing it this way then. If I cat in.txt and pipe it into solution.py, you'll see that it outputs everything that's been read from the standard input, which when you pipe a file in is just everything in the file, and then it sends an end of file flag afterwards. I'd show that live, but I don't actually know how to input an end of file in PowerShell. So maybe I shouldn't have been using Windows here. Anyway, if I open input stream 1, I can then write to it because it is the same thing as standard output. Sorry, I forgot you need to specify that I want to open it as a write buffer. So you can see that this is another way of printing. And if you open 2 as a write stream, it'll write to standard error. Now you'll see that you can't really tell the difference here, but if I pipe the output to out.txt, you can see that it still outputs it to the console and out.txt ends up empty. This is because I have piped standard out to out.txt. If I do this, then you can see more clearly that out.txt gets the standard output, which is empty, and error.txt gets the standard error. I don't know what any of this means. Control Z for EOF? Huh. Oh, hey, that's cool. Thank you. That's useful to know. Okay. Okay. So, anyway, now what we can do is we can grab all of the names. So this is why you'll often see me do something like this for a line in open 0. Because what I'm doing here is when you open a file for reading, it becomes an iterable, and when you iterate through it, you get each line individually. Now, it is important to note that when you do this, I forgot to pipe my input file. It's important to notice that there are extra new lines here. This is because line will receive the new line at the end of the file, meaning when you iterate through this, you'll get all of the characters. If you want to avoid that, you'll either have to do line.strip, or you'll have to use .read to read everything into a string and then split it on new lines. Note that this does require it to read the whole file at once and store all in memory, but in Advent of Code, the input file is never large enough that that really causes any issues. But if it matters, this does not require you to read everything into memory. So anyway, now what we can do is we can get a list of winners. So winners equals line.strip for line in open 0. Not winners, sorry, entries. And then of course, because that has the extra dash at the beginning, we can pop that off using this, which gets everything except the first 2 elements. This is not any AOC day, this is the giveaway, yeah. And so these are all of the entries. And now what we can do to randomly draw is we can just do random.shuffle, which will modify the array in place and return nothing. And what this does is it will randomly shuffle the entries. This is not technically cryptographically random, nor is it pure random like random.org is, but for these purposes, it does not really matter if we're using a pseudo-random number generator. And then what we can do is we can just grab the first 6 people as winners. So winner for lifetime, entry 0, winner for 3 months, and then finally winner for 1 month. Like so. And so let's see what we get. Cool. So these are the drawn winners. Congratulations to the 6 winners. I will verify that these are valid GitHub usernames, and then I will reach out to these people somehow afterwards. Let me save this so that I don't lose it later. If you can't reach out to them, you can always reach out to me instead. Nice. Okay. Well, with that out of the way, Pat, you don't need to type them. I already saved it in a file. Somebody asked what my words per minute is. Let's find out together, shall we? About that. Gerardo, they win memberships for Codecrafters, which is a learning platform that I've advertised a couple of times. I am sponsored by them, of course. Yeah, you can basically build your own projects through them. So, for example, something that I was working on for a bit, you'll see I haven't really spent too much time working with this yet because I've just been very busy. But I was learning Rust using this by building my own BitTorrent. So basically you just clone their repository, and once you've cloned their repository, they give you individual stages, and you basically read through their instructions and implement a project step by step. It's a great way to learn a language in a real environment, and each time you push to the repository, it will run tests against the current stage you're working on, and once you pass each stage, it will show you the next one that you can work on. Pretty interesting. I have an affiliate link that I've given a couple of times. Let me paste it in the chat if anyone is interested. Also, I did not learn to type 160 words per minute. That just happened from me having no life and using a computer too much. Okay, so let's look through today's agenda. I pre-planned a bit of this. I'm going to look through every problem again, but I won't necessarily resolve all of them because some of them, there isn't really too much for me to improve on from the video. But these are the ones that I found in advance that I am going to look through again. So you should see that update in the bottom right corner of the stream. So day one, I got a couple comments about my code readability, and indeed the code that I wrote in my video was like very unreadable. And so I would like to revisit this problem. No idea what that does, but I just inserted a stream marker from the YouTube live controls. I think that'll make it easier for me to add chapters afterwards. But yeah, let's look at problem one again. So of course, being problem one is not too hard of a problem, but the way I did it the first time was rather unreadable and not very elegant. So it would be nice to go through this again. So as a reminder of what the problem does, we have two lists side by side. I'm just going to skip over the flavor text for time purposes. And we want to pair up the numbers and measure how far apart they are, looking at them in order from smallest to largest pairwise. And we'll add up all of the distances. So I think part one is the one that I mostly had issues with readability with. Let's grab the puzzle input. Unfortunately, I'm going to have to do this the primitive way by actually opening the file and copy pasting it myself, since I don't feel like rewriting my script for Batch or PowerShell or whatever. So yeah, let's do this not in a stupidly unreadable way. So the first thing we need to do is read in our lists. So we can have two lists, A and B, and then we can say for each line, XY is going to be line.split, which is going to give us our individual numbers. And then if we convert each of them to integers, we can get our two numbers, and then we can do a.append x and b.append y. And this is a lot more readable. Then we just need to sort both of our lists. And then we're going to still use the zip function to pair up the numbers. So we can say for xy in zip AB. As a recap, in case any of you forget or are unfamiliar with what zip does, it takes a list of collections as individual arguments and it goes through them column-wise. So for example, if you provide it two arrays A and B, it'll iterate through the first element of each list, then the second element of each list, then the third element of each list, etc. And then we can add up all of the distances. So if we start our total at 0, then we can say total plus equals the absolute difference between x and y. And finally, we can print out our total. So yeah, that gets us the right answer. This is comparatively a lot more readable than this, at least. Yeah, this is a lot more readable, and honestly, like when I did this in the contest, I probably did it closer to this than this, because trying to figure this out in real time is just not a good idea. Generally, you want to write readable code when you're solving it in AOC, because if you make any mistakes, it's a lot easier to figure out what went wrong here than here. But yeah, so let's drop that off here in the revisited folder, and we can move on to part 2. For part 2, we're adding up each number in the left list after multiplying it by the number of times it appears in the right list. I don't think this one was too unreadable. Nope, it was unreadable. Never mind. Yeah, so we're going to add up what was it again? The number in each list on the left times the number of times it appears in the right. Okay, so we no longer need to sort. We can say total equals 0 for x in A, print or total plus equals x times b dot count x. And this should work. Yes, it does. Now, I do want to demonstrate something slightly interesting with this one. One thing you can note is that the number of times x appears in A, we don't need to loop through it every time. So what we can do is Wait, would that even save time? I think that would, because count is a slow operation. What we can do is for each unique x in A, because we are adding x times the number of times it shows up in B each time, and the number of times is the number of times x shows up in A, what that means is we don't actually need to look at x again. We can just take x and multiply it by the product of how many times it shows up in A times how many times it shows up in B. Basically, what this is saying is for each number in existence, add it times the number of times it shows up in A times the number of times it shows up in B. And so, as someone in chat correctly guessed, it is set time. Although rather than using a set and then doing dot count, what we can do is we can preemptively count, because dot count is a linear operator, and getting a map of each number to the number of times it appears is also linear, which means we can pre-compute it to go from quadratic time to linear time. So if we do A counts equals map, B counts equals map, what we can do is for x in A counts, if x not in A counts equals 0, or A counts x equals 0, and then A counts x plus equals 1. And then we can also do the same for B. And so this would work. And it would give us the number of times each thing appears, which seems to be 1 for most of them. But what we can do also is there is a utility for this in Python. I just don't really remember how to use it. It's the collections counter, and it basically does exactly what we are trying to do here. So, advent of optimizing the crap out of it. Yeah, given that this runs instantly anyway, it's kind of pointless, but you know, why not? So, what we can do is we can say A counts equals collections.counter A. And now instead of having to like write any code ourselves, we can just have a built-in Python collection do it for us. And then we can just do total equals 0 for x in A counts, total plus equals x times the number of times it appears in A times the number of times it appears in B. Now this probably will error. No, it won't actually. Oh, cool. The counter also has the nice property that if you give it something that doesn't exist in it, it'll give you a 0 instead of a key error. So we do not need to use .get to check that. The counter just automatically does that for me. So that is pretty convenient. So yeah, that is technically a way to optimize it. More importantly, though, it's just a lot more readable. Also, yeah, if you use Control-D, you can select everything that matches a string. If you have your cursor hovering or selecting something, Control-D will go through everything with that selection. If you have your cursor just in one position, then Control-D will first select the word your cursor is on, and then pressing Control-D repeatedly lets you do multi-select and multi-editing. You can also Alt-click to place multiple cursors, although I don't know how to do that on Linux since Alt-click drags the window instead. Yeah, so that's day 1. That's day 1. And let's take a look at day 2 in that case. I don't know if we'll actually end up changing anything with the code since this wasn't on the agenda, but let's just take a look at what this does. Okay, so yeah, I honestly might try to disable the alt-click moving my window. I didn't modify my desktop environment at all. I am literally using like base installation Linux Mint. Like I haven't even changed my desktop background. Yeah, as far as being like a programmer goes, I am considerably basic when it comes to using Linux. The most advanced Linux version I've used is like Debian, like, and I didn't use that much. I basically always just install the latest version of Linux Mint and then change basically nothing with it. I'm not a like I haven't used Arch or Nix or any of the other fancy varieties. I have been meaning to try Nix at some point. Anyway, um, this one I believe was fairly simple. Yeah, it's just for each report, is it all decreasing or all increasing? And then if you nuke one of the numbers, is it safe? This one was pretty straightforward, and I don't think my code for that needed many changes. Yeah, this is all fine. We can skip past that. Day 3, I did have something written there. Yeah, rewrite that with capture groups. So I had a couple of YouTube commenters. Thank you to Clipron Howard and Old Major 5240 for mentioning capture groups. That is a feature of regular expressions that I didn't use and don't often use, but I think it would be neat to introduce them here. Jelly Sebrets also mentioned a cleaner way of removing the don't actions in part 2, which I will explore as well. So as a brief recap of regular expressions, it's basically a way to match strings using a pattern. So for example, if I have a string like x, a, b, a, c, x, a, then if I select the regular expression, the slashes denote the start and end of a regular expression usually. If I select a star, b star, what this means is the star takes the character before it, which is just the literal letter A, and says any number of appearances consecutively, including 0. Same thing goes for B star. So this would select this because it's some number of A's followed by some number of B's. This because 0 is also a number of A's. This as well because 0 is also a number of B's. This, and this. If I instead changed it to A plus, B plus, that means one or more of A and one or more of B, which would only select this. If I change it to a B plus, this is a capture group, or sorry, this is not a capture group. This is a character class group, I think. I forget what it's called, but this represents one unit, which says any character in the square brackets. So this is either A or B. So this is one or more of either A or B. So that would match this, and any subset of those, and also this. Yeah, thanks for mentioning that. Regex 101 is a great website for testing regular expressions. So for example, if I do A star B star, you can see that it selects a bunch of matches. Oh yeah, the empty string is also a valid match because you can have 0 A's followed by 0 B's. But yeah, AB works, AA works, single A works, single B also works. I don't know if... Yeah, the reason that's not matched by this is because the match is greedy. And so it will match the empty string and then it will match the AB, which means that it then starts looking beyond the AB. But yeah, A plus B plus, for example, just selects the AB. AB plus selects ABAA and the subsequent A. If you put a question mark after a plus or a star, it will make the regular expression attempt to match as few things as possible. Normally, plus and star are greedy and will try to match as many things as possible. This is a surprise tool that will help us later. But going back to capture groups, let's suppose... Oh yeah, also this. Thanks for mentioning that. There's a reference here which is very useful. There's a lot of stuff that regular expressions support, a lot of which I don't even have any clue how to use. But if we look through this, basically we're trying to find MUL, bracket, and then 2 numbers, which the problem says are... Where does it say it? Yeah, it says that the numbers are supposed to be 1 to 3 digits, but I don't believe it ever checks that. Yeah, it never actually checks that, which is interesting, but whatever. Advent of Code does that a lot. If we insert the test string here, what we're basically trying to find is MUL, and then an open bracket, and then 1 to 3 digits, a comma, another 1 to 3 digits, and then a close bracket. This is all pretty standard. This is what I was doing initially. This is what I did in part 1 in the video. But what you can do with capture groups is if you put normal brackets, you'll see that I put backslashes before these brackets. That is because I need to escape the brackets, and so I needed to escape it to make it a literal. That's because the brackets have a special meaning. These are capture groups. A capture group in regular expressions basically denotes a group that you want the engine to keep track of. So for example here, you'll see that for each match we have two groups, the first number and the second number. So when it matches string mul2 4, the first group will be 2 and the second group will be 4. Similarly with mul 11 8, the first group is the 11 and the second group is the 8. This means that we no longer need to do the parsing that I was doing previously in day 3. So you'll see here that I grabbed each match and then I took the match, I sliced off the start and end part, and then I split it on commas. If we used groups, we would not actually need to do this. So let's grab the input. Where is my input file? Yeah, so if we grab the input, then you can see that this does work indeed. If I save. Yeah, so you can see that this gives the correct answer, but this is more complicated than you really need it to be. And given that seconds matter when you're doing Advent of Code, having to line up your parsing is just not convenient when you could instead make these capture groups. So if we make these capture groups and then we print out each match we see, you can see that rather than being a single string like before, our match is now a tuple that contains the capture groups. The first capture group is this, the second capture group is this. Note that if you want to get the whole string, you can just make the whole thing a capture group. And also note that you can have nested capture groups. They will appear in order of whichever one has the left bracket on the leftmost side. So here the first capture group will be the whole thing, the second capture group will be this, and the third capture group will be this. Another good thing to note is that if you are doing optionals, so for example question mark, or you are doing A or B, capture groups that are empty will show up as empty. So you do not need to worry about them being missing from the list and messing with your list indexing. For example, if we wanted to look for ABC followed by either X or Y and then another ABC, if we, for example, do ABC and then either X or Y, ABC, you can see that the group 1 contains the X or the Y because it is inside the brackets. If we had something more complex, I'm not going to put something more complex, but just for the sake of example, you will see here that, okay, it seems like regex 101 excludes the empty groups, but they are still there. You can see here that group 1 is Y and group 3 is Y, but group 2 is missing here. And the reason for that is because group 2 is this bracket X, and because we are using the OR operator and the X is not what's matched in the second string, group 2 is empty. But it still shows up. It doesn't delete itself. There is still a group 2. Capture group 2 still exists in the list, and so you don't need to worry about your alignment being messed up. That said, if we use capture groups, we can very easily get the matches. And so that means that instead of needing to do this parsing step, we can instead just do for x, y in re.findAll. We can just do total plus equals int x times int y to get our answer with less parsing, and less parsing tends to be good. So you can see that that still gives us the correct answer for part 1. I forgot to change the title. And then for part 2, as a recap, the do instruction enables mul instructions and the don't instruction disables them. And at the beginning, the instructions are enabled. So something that was mentioned to me that is pretty interesting is rather than like checking the do or don't instructions, you can pre-process the string and just completely delete everything between the don't and the do. And so what you can do here is you can take memory and just do re.sub, which stands for substitute. The substitute function takes 3 arguments. Hello, can am I not going to get type signatures here? I guess not. re.sub takes 3 arguments. The first one is the regular expression that is being matched. The second is what you're replacing it with. And the third is the string that you are substituting. So for example, if we want to replace all of the A's with B's, then we can do re.sub, replace any instance of A with a B. And then what else we can do is we can make the second argument a function. So for example, if we want to replace if we want to match a number and replace it with that number plus 1, we can do that. So we can take any group of digits, and then, for example, if we do that, and then we take lambda x, and we take x, convert it to a number, add 1, and then convert it back to a string, you can see it gives a match object. You can see that we can increment each number in a string using regular expressions as well. So the second argument can either be a string that we're replacing it with, or it can be a function that takes in the match object and outputs back something to replace it with. And I believe you don't need it to be converted back to a string. No, you do need it into a string. Okay. But yeah, we are not going to be using the function mode in this problem, or like ever. But what we can do for pre-processing is we can say we can replace everything between the don't and the do with just an empty string. So that'll be don't brackets and then any number of instruction or characters between them. That's what dot means. Dot means any character and star means any amount. So any amount of any character followed by do. And would you look at that? The value is wrong. Now, why is that? Remember the surprise tool I mentioned earlier? This dot star is matching as much as possible, which means this is taking the first don't and the last do and deleting everything between them. That means that the do operations in the middle aren't actually re-enabling the multiplication instructions. And so if we make the star not greedy, we can see that now we get the, okay, that was supposed to give the correct answer. Yeah, things don't always work out in my favor, apparently. That's slightly awkward. Now I'm just confused because this was supposed to be a very straightforward. This is supposed to be really straightforward, but my group debugging session. Yeah, the advantage of a live stream is you get to see me suffer. Usually I'd pause the recording here, but I can't do that, so you get to see me suffer. Why is that giving a... The answer it's giving is too high, which is odd. Yeah, I'm sorry. Sorry to inform you, but when I do my recording, which is not live, I do sometimes exploit the power of post processing. I know. I'm truly ashamed of my actions. I also sometimes restart my recording up to like 3 or 4 times. Okay, let's try on a smaller example. Oh, I get it. I get it now. I think that's because I did not enable the multi-line flag. What? Am I not replacing all copies? No, that's the default. The default is a global match. What if I get rid of the new lines? Still not quite. Yeah, you're right, Olympus. I think that's the problem. Uh, yeah, there we go. Thank you. Christopher, I already turned off the greedy. That was the surprise tool that I said that would help us later. Yeah, okay, so two things here. Firstly, this match unfortunately does not go over the new lines. So what you can do is you can either substitute out the new lines and just merge them on the same string. Or what you can do is, okay, so there are two ways around this problem. The dot by default actually doesn't match any character. I kind of lied. It matches any character except new lines. You can turn on the multi-line flag. The problem is I forget how to do that. So that's the power of Google. What is it, like re.m? Count as passed as a position argument. What does that mean though? Also, that is even more wrong. I'm so confused now. The multi-line flag is re.m. I don't think that did what I wanted. Okay. The other thing you can do is instead of using dot, you can just abuse something like this. So if you make a character class, you can also put escape sequences in that. So this is everything that's a white space, and this is everything that's not a white space. So this character is just everything that's either a white space or a not a white space. You can also do something like dot backslash n. Do be careful though, because backslash... Oh, come on. That's because it's getting escaped. No, you can't do that because you can't insert a new line into your regular expression. Yeah, you cannot insert a new line into your regular expression. So you can do like everything that's a word character or not a word character. You can do like everything that's a digit or not a digit. You can do like everything that's a white space or not a white space. You can do all of those. It's just those all will work. re.all? That's so weird. Okay, I was wrong. So the multi-line flag makes it so that instead of matching start and end of string, it makes the caret and $ and match the start and end of each line, which is not what we want. We want dot all. Dot all. Come on, that didn't work either. You know what? Screw this. Too hard to remember. Just use this trick. It's a stupid hack, but if it works, it works. Oh yeah. I did do the contest in Windows, and one thing you need to be very, very careful of in Windows. If you split your string on \n, but you've saved your file in CRLF, you will get errors. Oh, come on, I need to do flags equals. I hate Python sometimes. Okay, thank you. Okay, thank you, MathCat. Yeah, I'm not very familiar with the advanced parts of regular expressions, as you can clearly tell. So yeah, flags equals re.all. There's a flag that makes dot match all characters. By default, the dot, which is supposed to match all characters, doesn't actually match all characters, but you can use a flag to make the character that matches all characters actually match all characters. Thank you, regular expression standards. Very cool. But yeah, so this works. You can also just use the dumb hack, but you know, we're doing a revisited live stream. We're trying to avoid dumb hacks. Let's go with this. And then the other thing, yeah, we're already an hour in, and we're only on day 3. I'm gonna have to go faster through the rest of these. The other thing that I missed that Olympus mentioned was the end of line. So one thing to note is that this only replaces the previous regular expression I had, which was this, only replaces stuff between don't and do. But the problem spec never says that there will be a do at the end of the string. And so if there's a don't instruction that's not followed by a do, it wouldn't get matched. So what you have to do is you also have to add a case to match with the end of the string instead of a subsequent do. So this will match anything that starts with don't, and then ungreedily matches any number of any character, and then matches either a closing do or the end of the input. Okay. So this works. This regular expression is honestly kind of clunky, so I'm not even convinced it makes too much sense. But, you know, we have the power of unlimited time. Alright, take care. Have a safe train ride. Also, last year I did do multiple streams, but I didn't get around to that this year during the contest. Like last time I did my streams on weekends for like a week at a time. I don't have much time, so I'm just gonna cram it all into one stream. But yeah, I think that's satisfactory. Let's go with that. Regular expressions are lovely, except when they're not. All right. As for day 4, this was the word search problem. Nothing to really revisit here. I think my code for this one was fine. Yeah, this was fine. Day 5. Foreigner OBJ on my YouTube video commented an interesting approach to this problem that I think for the sake of time I'm not going to cover because my code for this one already does work, and is also perfectly fine in terms of readability. But one thing I do want to comment is that there is something that my part 2 solution relies on that technically was not put in the input specifications. My part 2 relies on the fact that every pair of values is in the map somewhere with an ordering. As a recap of this problem, basically we have a bunch of page ordering rules that tell us the relative order of some pages. So for example, this says page 47 must come before page 53. This says page 97 must come before page 13. And what part 2 was for each list of pages, we were supposed to sort it into the order which satisfied the page rules. Now, the way I did this was I used .sort using a comparator function, and the comparator function was to just look in the cache for the rule, which was either 1 or -1 depending on the ordering. And I assumed a default of 0. The problem with this is that Python sort obviously does not do every single comparison. It'll make some assumptions so that it can not be completely nonsense time complexity. The problem with that is if any pair is not in this map, then the sorting algorithm will actually not sort the list correctly. And that is because Python sort assumes that your comparator is transitive. What that, or rather, my VS Code is connected to Discord using the Discord presence extension. I also forgot to insert more stream markers, which means I'm going to have trouble adding my chapters later, but whatever. But yeah, Python assumes that your comparator function represents a total ordering, or maybe a partial ordering? No, a total ordering. What that means is that if A is less than B and B is less than C, then Python will assume that A is also less than C. Now, normally this perfectly makes sense. However, if in our case, we basically have our less than operator represented as a map. If two values aren't in this, for example, if we have A is less than B and B is less than C, but we are trying to compare A and C and it's not in this map, then we might tell Python here with the 0 that A is congruent to C. And this can cause issues because if we then get that A is less than B, Python will assume that C is less than B. And so what that's essentially doing is, if this is our real ordering, where the list tells us A is less than B and B is less than C, but we see A and C without being in the list, then this default tells Python that A is congruent to C. So then if A is less than B, if we get to this step here, then Python would infer that C is less than B and sort it in the order A, C, B. If we got that B is less than C, then we would instead get this, which would make Python think that A is also greater than B, which would cause us to sort it in the order B, A, C. And neither of these is actually correct because we are trying to get A, B, C. Yeah, sure, whatever. And so technically speaking, because the problem does not specify that the map contains every single pair of pages, I believe, it does mean that technically speaking, this is not rigorously complete. And what I mean by that is it is technically possible to construct input within the specifications, for which my code won't work. Now, I'm not going to re-implement this because it actually does work for all inputs, because this is another one of those advent of code inputs meets some condition that it didn't specify thing. But there is an algorithm to convert a partial ordering into a proper ordering, which is called topographical sort. Or topological sort, sorry. Topological sort basically takes a partial ordering, which is an ordering in which not all elements can be compared, and linearly orders the values such that they are correctly in order. So topological sort is not extremely difficult to implement, and so I will leave this as an exercise to the reader. Also, the reason I say exercise to the reader is mostly just as a joke, because textbooks love to put very non-obvious results in and say they're obvious and leave them as an exercise to the reader. I'm well aware that y'all are watchers or viewers and not readers, but it's funny. So I will leave implementation of this alternative solution as an exercise to the reader, but essentially by topologically sorting a list of comparable objects, you will be able to put them into an order that satisfies that. And that is exactly what we need in this situation. However, there is another problem with topological sort, which is that there can be cycles in this. And what I mean is that the page ordering rules might not be internally consistent with themselves. I didn't say my audio is visible. Someone else said my audio is visible. I know that I don't have captions. Unfortunately, I cannot live caption my stream, but YouTube will auto-generate captions when I upload it afterwards. MathCat, you are correct. Funny guy, how do I pronounce your name, by the way? I'm gonna drink some water in the meantime. Yeah, Jess? Okay. But yeah, so the issue with topologically sorting is that there can be cycles in this. The page ordering rules are not necessarily internally consistent, which means that if you attempt to topologically sort this entire thing, you will get issues because toposort breaks if you have a cyclic graph. Now you might wonder, how can you possibly solve this problem if there are cycles? And the answer is that none of the lists of pages will actually contain any of those cycles. And so even though this page ordering rule list might have cycles in itself, for each list of pages that you are given, the subset of the graph that contains these will not be cyclic, because if it were cyclic, then there would be no valid answer. And so it necessarily has to not be cyclic. This is not specified in the problem specification. It's instead a case of the answer couldn't exist if it weren't the case. And so what my viewer observed is that what you can do is you can, for each list of pages, grab the subset of all rules that contain all pairs of this, and then you can topologically sort that subset of the graph, which will not be cyclic, and then you will be able to get a total ordering. And I think that's a very clever way of doing this, and I believe that is the only way to really rigorously solve this, because the two problems with this are A, we're not sure it's a total ordering, and B, we're not sure that it's not cyclic. And so the only way to do that would be to use the acyclic subsets and do topological sorting. Anyway, that is the way that you would do this rigorously, but for time I'm not going to implement that, and I'm going to leave that as an exercise to the reader. Moving on to the next problem, problem 6. This is a relatively simple optimization, so I'm going to implement it just because it's pretty simple. As a reminder of day 6, basically we're trying to sneak into a lab and there's a guard that's patrolling. For part 1, we figured out that how long the guard would take to exit the room. Basically, the guard follows the strict protocol of moving forward, and if it hits an obstacle, turn right and then keep moving. And then just keep moving until they leave the lab. Also, this lab was hiring female guards in 1518. Very progressive of them. But yeah, basically for part 1, we just see how many positions the guard will scan and then before she leaves the room. And so that part was very straightforward. There's nothing to really modify with my code there. This is all just very straightforward stuff, literally just simulate direct implementation. For part 2, we need to place an obstruction in the guard's path such that she will form an infinite loop. And so the way I did this was the very naive way of just dropping a cell in every position. The interesting approach that you can do here is that if you take your answer from part 1, it only makes sense to put obstacles in a position that the guard would reach. This is fairly obvious. If you put an obstacle in a place that the guard would never reach anyway, she's obviously not going to encounter it, and so it's not going to put her into a loop. And so this saves actually quite a bit of time. So let's take a look at exactly how much time it saves. So if we grab our input file for day 6 and we drop it into in.txt, if we time this, is that not a thing? And okay, whatever, I'll time it myself then. Okay, so you can see that this takes quite a bit. The correct answer we are expecting is 1688. Wow, this is even slower than I remembered it being. I think I paused the video during this section because it was taking too long and I didn't want to make the video have like 30 seconds of waiting. But this time you get to suffer. Okay, yeah, it was literally 30 seconds. So yeah, we get the correct answer, but it took 26.8 seconds, which is pretty damn slow. So we can optimize this by only trying obstacles in positions where she would hit the obstacle. And so if we go to part 1, we can copy paste this section, which obtains the list of positions that she would encounter. And now that we have this, scene tells us the set of all positions that the guard ends up standing in. And so these are the places that we can attempt to place the obstacles. And so let's rename this to positions. Positions will contain all of the positions that we should bother trying. So we can say for CRCC in positions. We can also now skip this check. Or no, we shouldn't skip this check because we can't put an obstacle directly on the guard. That... Okay, now it's not the right answer. Group debugging session again. It is very fast, but there's no point in getting the wrong answer very quickly. Oh, that is because R and C was modified by this. Of course. Okay, so we need to store the start row and column position and then use them here because we modified our variables. Same variable names. Always the bane of my existence is shadowing variable names. It would be very funny if this weren't faster. Okay, so yeah, now we get the correct answer and it only takes 5 seconds, which is still kind of slow, but it's way better than what we had before. So basically all we did was we grabbed the solution from part 1 to get a list of all positions that the guard would encounter, and we only need to bother trying those positions for the obstacle that we are placing to try to make her loop. And obviously, if we place an obstacle in a position that she would never reach in the first place, it's not going to affect her path. And so this saves us a lot of time by avoiding searching through unnecessary possibilities. And so that gives us a faster way of doing part 2 of day 6. Next on the agenda is day 11. The next couple of days seem to have been pretty straightforward. Day 7 is the operators one, which we basically just depth first searched for the equations that can be formed. Day 8 was the one with the cell towers, I think it was. The antenna, whatever. The antenna that had certain frequencies and we wanted to figure out their antinodes. also very straightforward. Day 9, the disk fragmentation problem. Not very straightforward, but my code for this one didn't really have any issues, and so it doesn't seem like there's anything to revisit here. How long did the original take? 27.8 seconds or something like that? Or I guess if you want to get a percent faster. No, it saved about 82% of the time spent. So Pat, you're actually very close to being right. But in terms of how many percent faster, you'd have to take the reciprocal of that. So that's roughly 570% faster. Okay. Day 9, sorry, wrong problem. Day 10, this one was also very straightforward. Another grid graph theory problem, but nothing really wrong with the code. Day 11 is on the agenda because there is an errata with the explanation I gave for this one. What I said for this problem was that, as a reminder, this problem's the one where part 2, basically we have an arrangement of stones, and each time we blink, the stones either split apart or change their numbers. And what I said for part 2 is that the way we can compute this is because the stones never merge together, and they also never change their ordering. Oscar Olason correctly pointed out that my explanation was not exactly accurate, in that the ordering doesn't actually matter. It doesn't matter if the order of the stones changed, because all we care is that each stone represents a tree underneath itself, and therefore we can memorize the calculations for each number at each depth. If the numbers were to merge, then that would mess with our ability to do memoization, because we need to track neighbor states, which would make things a lot more complicated. But the ordering actually is completely unimportant here. If the stones split and then swapped positions, we would still end up just adding the recursion results of each of the sub-results. The divide and conquer would work either way. The dp/memoized recursion would work either way. The ordering is actually not important. So just a correction for my explanation, but no need to change any of the code. Day 14. Day 14 is a problem. Actually, let's go through these first. Day 12. This one was fairly interesting. I think this is the one with the fences. I introduced 2 ways of doing this problem. Part 1 is not very interesting. Part 2 is the neat one where you have to get the number of sides of each region. The way I initially did it was quite overcomplicated, where I grabbed each side and then spanned it out by looking up and down until I hit the edge of the side. But counting corners ends up being way easier for this problem. Shoelace principle can be used for the first part, but the first part is already easy anyway. Shoelace principle is the one that's used for perimeter, I think. No, it's used for area. Area is already easy in this problem. You could theoretically use shoelace formula, but area is already easy because it's just the number of cells that you select. Coincidentally, just watched the video on shoelace principle just before the problem. That's neat. Unfortunately, it doesn't really help you too much here, though. But yeah, this problem, not much to cover. My video already goes through this in enough depth. So if you're interested in revisiting this problem, just check out the video. Clock contraption. I mentioned but dismissed in my video that if A and B point in the same direction, this problem becomes a lot harder. A couple of people mentioned some stuff about that in the comments and conversation. I guess we have some time to briefly touch on that, but I'm not going to actually solve it because there's not much point. The reason this problem is not very hard to solve is because basically all we're doing is we have two vectors and we want to make them add up to reach some point. And so if we look at the first vector, it forms a line through the origin. And then if we take some arbitrary point to start doing the second vector instead, I have the memory of a goldfish, so thank you for reminding me, Pat. We need to find some arbitrary point at which we can switch from doing the first button to the second button to go through the line, or rather go through the destination point. And so what we've basically done is we've created a line using the first vector that passes through the origin and using the second vector that passes through the destination. And we just need to find the intersection point. This works fine when these two lines are not parallel. When the lines are parallel, then we have two possibilities. Either it doesn't point at the destination at all, and so it's not actually possible to reach, or it does point at the destination. And if it does point at the destination, then things get a lot more complicated. If this is the case, then it doesn't really matter what the x or what the y coordinates are. We only need one of the two. Basically, we just need to see if we can have some integer coefficient of the first vector plus some integer coefficient of the second vector add up to equal the destination vector. And so we can just look at the x coordinates, or we can just look at the y coordinates, or we could just look at the length, although the length will likely not be an integer. This, I believe, is what we call linear Diophantine equation, but don't quote me on that. I'm not good at math. A Diophantine equation is a polynomial in two or more unknowns with integer coefficients with only integer solutions of interest. Yes, this is correct. So, yeah, what we would be doing is exactly this first case. We'd be looking for integer coefficients of two variables that add up to a third variable. So let's say, for example, we have a very basic case where our A button moves us in the direction 2, 1. Our B button moves us in the direction, or that's boring. Let's do 4, 2, and 6, 3. And the point we're trying to reach is 150. So we can see that these are parallel and do point at this point. That's meant to say 50, and that looks kind of like 80. These all point in the direction of 2, 1. And so we know that the A and B button will point in the direction of this, but we don't know if we can actually reach it because we can only press the button an integer number of times. And so what we're basically asking for is, since we don't care about since the direction is the same, we can just simplify this to only the horizontal axis. We can say that we're trying to look for 4a plus 6b equals 100. We could also do 2a plus 3b equals 50. It's the same thing, it's just divided by 2. This is a linear Diophantine equation. And solving this is a bit more complicated than just plugging things into a system of linear equations. Again, I'll leave this as an exercise to the reader because this is just unnecessarily complicated for a case that is pretty deliberately excluded from the problem inputs. But yeah, basically, this is how you'd have to solve it if the buttons could point in the same direction. And so it's a good thing that they didn't, because this is annoying. Anyway, moving on from that, because there's no point in really trying to solve for that case, let's go on to problem 14. Problem 14 is the one that I initially said I really dislike, but my opinion on that has changed slightly. I still dislike the fact that it's not very good for accessibility, because if you're using a screen reader, you can't really read what a tree is, or you can't really see what the image of a tree is supposed to mean. But the advent of code is meant to be a problem more focused on puzzle solving than just implementing like interview coding questions. And so it is neat that it has questions like this. Now, I still don't like it that much because A, what the hell is a tree? B, not disability friendly. And so I'm more of a fan of problems like day 24, which require a lot of thinking and reverse engineering and don't require like weird, undefined requirements. 14 is one of the ones that fried ChatGPT, yes. And MathCat, you can quote that. I did say, what the hell is a tree? So yeah. The way I solved this one was with some assumptions that the first part would have something to do with the second part. Yeah, right. The first part was the safety factor, which was taking the product of the quadrants. If this product is high, then it means the distribution is relatively even between the quadrants. If the safety factor is low, it means that they're relatively concentrated in one quadrant. I assumed that the tree would probably be in one of the quadrants, and therefore we wanted to look for the minimum safety factor. This ended up working for my input, but it doesn't actually work for everyone's. And so the way that this is intended is to look for variance. Because when there is an image of a tree, the variance of the positions of the bots is relatively low. What that means is the bots are more concentrated on one location. That location might not necessarily be within a quadrant, which is why the safety factor might not necessarily be low. The tree could be centered in the middle of the bathroom, which would make the safety factor relatively high. And so the way we can do this is to look for the position with the lowest variance. So let's take a look through how we would solve this. Looking at the day 14 input. Also, something that a lot of people did, which was an interesting approach, is they just looked for the first instance where all of the bots were not overlapping. Their assumption was basically that the creators probably just drew a tree and then put a bunch of random dots down and then reverse engineered their velocities. I don't like this assumption, but it's no worse than my own assumption. It's arguably better. So fair game. You can just check for the first index where all of the robots do not overlap their positions. Neil used that one? Okay, I see. What's going on in chat? A tree is like a plant, typically having a single stem or trunk growing to a considerable height and bearing lateral branches at some distance from the ground. Oh, I see. Never gone outside, so I wouldn't know what that means. A tree is a set of finite sequences of elements of X that is closed under subsequences on a set X. What? A tree is a command on CMD equal to ls-la. Nice. A tree is an object that you punch 15 times to receive one block of wood. Nice. 15 times? Really? Gerardo, for me, it was the lowest safety factor. For some people, it was the highest safety factor. And for some people, it was neither. So that solution does not appear to really work. That's what I used in my video, but it doesn't really work, apparently. Anyway, what we can do for this one is look for the lowest variance. So in statistics, variance is basically the spread of the distribution. So if we have a set of points, like so, for example, the mean would be the average position of all of them. And the variance would be basically how distributed are they. If it's something like this, then the variance is relatively low because they tend to be a bit more clumped up. If they're like so, then the variance tends to be higher because they're more spread out. If there's a tree on the screen, that means that the points have to be relatively close together with maybe some loose dots around, and so the variance would have to be considerably low because everything is clumped up. A tree is an acyclic graph in which No loops are created where there's only ever a single edge between a pair of nodes. Correct, but also worth noting that it's undirected and connected. Also, yeah, just this is not a statistics problem, don't worry. Variance and mean are terms that I mostly learned from statistics, but this is not a statistics problem. So now we need to determine how to calculate the variance. Yeah, it was a problem of assumptions. If you did the right one, you'd get it. Yeah, which is why I don't really like this problem, because the lowest variance is also technically an assumption. Because they could have also made it so that there was a different frame where all of the dots overlapped on exactly one point, which would cause the variance to be literally 0. And so lowest variance technically doesn't even work for that. Anyway, variance is calculated by taking the average of the square distance between the mean and each point. So let's look at the Wikipedia article. The variance is the expected value of the squared deviation from the mean of a random variable. Now, what on earth does that mean? Basically, it's saying for each, we grab the average, and then for each point, we look at how far it is from the average, and then square that number and take the average of all of those. If we just took the average, that would be 0 by definition. And so if we square the distance from the mean and then take the average of all of those squares, the higher the number, the more spread out our sample will be. So for example, you can see in this chart that if this is the distribution of our datasets. The red one, which is more concentrated and less distributed, has a standard deviation of 10, and the blue one has a standard distribution of 50, standard deviation of 50, which is wider. The standard deviation is just the square root of the variance. This did end up being a bit statistics, I apologize, but let's close this before this gets into a statistics video. And so one way we can do this is by looking for the lowest variance. One thing somebody in my school CS club did was they looked for the lowest vertical variance and then looked for the lowest horizontal variance, see where it peaks, and then use Chinese remainder theorem to figure out the position. They also did this problem using Microsoft Excel. Not sure why, but they did it in Excel, so that's a thing. Yeah, he's an interesting person. Not always in a good way. So let's take a look at what we have here. So what I did was I looked through each of these, and my condition was looking for the minimum safety factor. So let's get rid of that part. What the hell is T? Oh, those are the quadrant counts. So instead of looking for the safety factor, we're going to look for the variance. And we're going to look for the lowest variance. So let's see if this even works, because it probably won't. At each position, we're going to take the mean of all of the points and then take the distance from the mean to each point and take the average of the squared distances. So the mean is going to be the average of all of the x coordinates and the average of all of the y coordinates. Note that these can be calculated independently to give us mean x equals... What am I even doing here? Oh, right. This is what I'm doing here. For robot in robots, px, py, vx, vy equals robot. And then we do robot 2 equals vx plus px mod width. Robot 3 equals vy plus py mod height. What I'm doing here is, instead of calculating the position each time, I'm just going to modify the position of each robot as we go. And so now we can look through each robot. So mean x equals, the average is of course the sum over the length. Sum is going to be vx for blank blank vx blank in robot divided by the length of the list. And then the mean y is going to be roughly the same, but for the y instead. Wait, sorry, it's supposed to be the position, not the... What am I doing here? Yeah, there we go. Okay, so it should be the position and that we're modifying, not the velocity, obviously. There we go. So now we have the mean, and we're going to take the average of the squared distances. So the distance between 2 points is the square root of the x distance plus the y distance, both squared. That's basic Pythagorean theorem. So of course, if we want the squared distance, we just remove the square root. So it's just the x distance squared plus the y distance squared. And so variance, or rather sum of squares, let's call it SOS, equals 0. And then for each px, py in robots, SOS plus equals px minus mean x squared plus py minus mean y squared. And so this is the distance between each point and the average of the points. And we're going to sum the squares, and then the variance is going to equal the average, which is the sum divided by the length. And now we just see if this is the best variance. So if the variance is less than min variance, then min variance equals the variance, and we're going to say best iteration equals second. Now let's see if this works. It probably won't. Of course. The solution might be slow. 7602. That's actually correct, except I forgot to account for the one-off error. Oops. Did I account for the one-off error here? No. This might just be wrong then. Oh no. No, it isn't. Because at second 0, this one has not modified the position, but I modified the position at second 0. This should be moved to the end because it only changes at the end of the first second. Okay, that was the problem. I was modifying the position of the robot in the beginning of the frame instead of at the end. Okay, now why am I getting 7604? That doesn't even make sense. Oh yeah, I did. I told you I have the memory of a goldfish. There we go. Okay, so that does indeed work. This obtains the lowest variance. And just because, why not? Let's also print out the tree. I will drink some water, actually. And while I'm at it, I've been sitting for a while, so I'm gonna get up and stretch for a bit. I will return to discuss an alternative way of solving this, but I will see you shortly. I have returned. Okay, before we try another approach, who wants to see the tree? Let's see the tree then. How can we do this? Initial state equals. Yeah, let's make a copy of the robots, right? Initial equals list map list robots. That should work. Okay. Since we're modifying the robots, this lets us just keep track of the initial. Okay. So best iteration tells us how many seconds have passed. So we're going to make a grid, and so initial for chords equals blank for px, py, vx, vy in initial chords dot append vx plus px times px plus vx times best iteration modulo width and then px plus, or py plus vy times best iteration modulo height. So that tells us the coordinates of each of the robots at the position of the best iteration. I believe this is correct. Yes, and now I just need to draw that onto a grid. Okay, so now I just need to say mx equals max x for x blank in chords, my equals max y for y blank in chords. Basically just getting the size of the grid. Grid equals space times my for blank in range mx. So this will make an mx by my grid, and then we can just say, or rather should be +1 for both. And then we can just say for xy in chords, grid xy equals #. And then at the end we can just print \n dot join map blank dot join on grid. So theoretically this will print out the tree. Now in practice I probably messed this up. Yeah, okay, cool. Yeah, because I don't know how to code, apparently. And of course it's rotated. Of course it is. Because I keep forgetting that grids need to be the other way around, where the rows are the y and the columns are the x. Yeah, in case you noticed, I tend to like using row and column instead of x and y. But look, it's a tree. Anyway, so that's one way of doing it, which is to use the variance. And that's a pretty nice way of doing it that I personally found to be better than my assumption. It is still technically an assumption, but it's a better assumption. I'm labeling this -1 because there's also another way to do this, which, yes, this is a tree. Yeah, imagine doing this with a screen reader. Like you're cooked. You'd have to make assumptions the same assumptions that I did. To be fair, I didn't look at the picture of the tree, so I guess technically I could have done this with a screen reader because I didn't look at the tree, but still do not like the assumptions of what people are able to do. Anyway, should actually move this to the bottom so that you can still read the output. Now what we can do is the other way of approaching this is to look at the largest connected group. So this is something that I think someone earlier in chat mentioned. This is also an idea that I picked up from a couple people either on Discord or in the comments. But basically the idea here is that instead of just looking at the positions of the points in isolation, we know that if there's a drawing of a tree, there's probably a bunch of adjacent points. And so what we can do is for each point, we'll look at how many points are connected to it. And once we've gathered the size of the largest cluster, we can just look for the frame with the largest cluster. Image recognition software would be interesting, but also really slow, I think. It would take them longer, yeah. I would not mind if the cheaters used really slow solutions that caused them to also rack up a bunch of AI costs. Anyway, you'd also have to draw out the image, but I think someone did this by saving a file for each frame and then looking through it in their file explorer. I think that's a way that someone did it. I guess that works. But yeah, so what we're going to do here is now we're going to remove the variance and we're going to look for the best cluster. So the max cluster is going to initially be 0. This is true. We don't know if the tree is filled in or not, but even if it's the outline of a tree, it will still be much more connected than any other frame would randomly end up being. So now what we're going to do is we're going to look at each robot and see how many robots are connected to it. So I believe what we can do here is we can store the robots into a set. So the chords equals the set of all robot positions. So the set of all x, y for x, y blank blank in robots. Now that we have the set of coordinates, we can look at each coordinate and find the cluster. So we can say cluster size equals 0 initially, and then for each coordinate in the cluster, for x, y in chords, or no, that's not a good way of doing this. While the length of chords is greater than 0, we can say x, y equals chords dot. Can you pop from a set? You can, and it'll pop some value. It doesn't matter which. So we're going to do x, y equals chords.pop to get one coordinate off. And now what we're going to do is we're going to look at all of its neighbors. It doesn't matter if we include diagonals or not, but I'm not going to. Actually, I am going to include diagonals because technically during the contest we would have no way of knowing if the tree was like not filled in and looked something like this, for example, where the neighbors are just diagonal. And so what we're going to do is we're going to look at all of its potential neighbors for n, x, and y in, or I guess we can do for nx in x minus 1, x plus 1, for ny in y minus 1, y plus 1, if nx equals x and ny equals y, continue. And then for each neighbor, we can say if nx and y in chords, I guess we'd have to do it this way. Scene or yeah, so the cluster begins as a set just containing x, y, and then we can also say search equals x, y. While the search set is not empty, we will pop x, y from the search set. And then we will look at... I feel like I'm overcomplicating this. This is just a standard breadth first fill, is it not? It is. It is, which makes me think I'm overcomplicating this. Anyway, for each time we will grab a new item that we are searching, and then we'll look at all of its potential neighbor coordinates, and we'll see if that is a coordinate that contains a robot. If it is, we will add it to the cluster. We can actually make the cluster just a number. If it is, we'll add it to the cluster. We'll add it to the search set. And then we'll remove it from chords. And so now we should get a cluster, which means that why not just count the neighbors and remove base from set each time? That's what I'm trying to do here. Is it not delete? It's not remove, isn't it? Yeah, it's not remove. Okay. Most of the clusters are going to be 1, so then we can say if the cluster is better than the max cluster, we will say max cluster equals cluster, best iteration equals second. theoretically this will work, but it'll probably be very slow. I do wonder how slow though. Okay, no, it's actually decent. So basically what we're doing here is we're taking a look at all of the robot's coordinates, and then while that coordinate set is not empty, we'll take a look at the next coordinate up. Oh, hey, it works. It actually gives the correct answer too. Nice. We'll take the next coordinate, we'll initialize a cluster of size 1. Search will be the set of all points that we have not explored yet. And then each time we will grab the next point to search, look at all of its neighboring positions. If one of them has a robot there, we'll expand the cluster and add it to the set of items to search next, and then we'll drop it from the base coordinate set to avoid double searching, which would be slow. And each time we hit a new largest cluster, we will set the best iteration again. This is slower than the variance. This is slower than the variance because this one just has more looping. The variance one is just simpler. It's just a couple of O of n loops. But it's still an interesting way to do this nonetheless, and I think it's not technically any better in terms of making assumptions. There is no way to solve this problem without making some assumptions, but it is what it is. I like this solution though, personally. I like the variance one a bit more because this one's just a bit clunky, but it is still cool. No, I don't use PyPy because with PyPy I tend to find to run into memory issues. I'd rather my code take a bit longer than start freezing my computer, which has happened once. I was running an inefficient solution and it almost froze my computer. All right, day 15. The errata here is really nothing particularly interesting. It's just me being embarrassingly bad at reading. During my video, I mentioned something about how in part 2, the problem statement seemed to... I'll update the counter, but sure. During part 2, I said something about how they said that the robot was twice as wide because for some reason I'm unable to read, and the problem statement actually said that everything except the robot is twice as wide. Yeah, that's really all there is to it. Thank you to Gregor Gramlich for pointing that out. I pinned the comment because that was extraordinarily terrible reading on my part. Anyway, I'm not going to redo this problem because I do not believe there was anything really notably bad about... Yeah, my code was fine the first time around. I just misread the problem statement. It didn't end up affecting my solution, but it did make me look stupid. Anyway, day 16, reindeer maze. This is the one wherein it's basically just a standard issue graph theory problem, but with the rotations considered as separate states. Some people did point out that because turning costs 1,000 points, which is just so much more expensive than moving, this really just becomes a minimized number of turns problem. You can do some interesting solutions with that, but I'm not going to explore those. If you're interested in looking into that as potential optimizations, I'll leave that as an exercise to the reader. But it's just simple Dijkstra. Like, yeah, just said, it's... I mean, Dasbo, the thing is, the example made it obvious what the problem meant. I just thought that they made a typo in the problem statement because it was obvious from here that the robot was the same width and all of the other things were double the width. But no, I just can't read. Anyway, part 16 I'm not going to revisit, or day 16 rather. The extra is already optimized to reduce the cost. It's just you might possibly get a way to make the solution more efficient. I'm not sure though. Anyway, day 17. Yeah, so very important thing to do. Read the operator precedence. I paused for most of it during the video, so it didn't end up taking too long of the video time, but it took me a solid 10 to 20 minutes to figure out the problem with my solution. It's because I said that two operators were interchangeable, and it ended up being the case that they weren't, because operator precedence. Why not use edge contraction here? Sorry, are you referring to day 16, like the reindeer maze one? I could use edge contraction, but it doesn't seem particularly necessary. You could, though. Edge contraction is basically when you take multiple edges in a graph and contract them into one. So this is useful, for example, if you have a graph where you have a bunch of points that aren't connected to any points except each other in a long chain. And so if you have some graph that looks like this, for example, you could like take these edges and contract them into a single edge of cost equal to the sum of the costs of the edges. This would work. You can pre-compute it, and in some applications this can save you a lot of time, but it doesn't really strike me as necessary. Anyway, operator precedence. Very important to keep in mind. Notably, the bitwise operators tend to have very low precedence. And so you'll notice that of the ones that are really operators, I don't consider these operators. The Boolean operators are quite low on the list, with not being ahead of and being ahead of or. That is fairly standard. This all makes sense, and then comparators are here. This all makes sense because if I do A equals B or C equals D, I obviously want A equals B or C equals D, not A equals the result of B or C equals D. The comparisons, identities, and membership, those all go together. But notably, the bitwise operators go below the mathematical operators. And so the mistake I made was in part 2, for this part, I initially said it doesn't matter if you use Boolean OR for T or addition for T. It, however, very much does, because the left shift, right shift operators are below addition but above bitwise OR. What that means is by using bitwise OR, it is correct because this happens first and then you do the bitwise OR. If you change this to a plus, now you get 3 plus t as the right argument to the left shift, which is not correct. And so make sure you're familiar with the operator precedence. For the most part, it will be obvious, but if you forget and get it wrong, you might spend a lot of time suffering like I did. So yeah, don't suffer, or just use brackets if you're not sure. I did say I want to do a more thorough walkthrough of the reverse engineering here, though, because I'm not sure I necessarily got everything particularly clear in my video. So this problem I particularly like because AI is very bad at solving this type of problem, and B, I just like reverse engineering problems. So basically what we're trying to do is we're trying to figure out the value of register A such that the program outputs itself. And so the way I ended up writing out my code was I just made a couple of assumptions and just emulated the code on different values of the specific octet in A, and then found the correct octet, left shifted it by 3, and then kept searching. JavaScript can't handle bitwise operators for large numbers. I'm pretty sure you can. Just use big int. Like if I do 8n left shift like 10n, or console.log. What? Yeah, if you use big integers, it works perfectly fine. Bitwise operators make numbers 32-bit unless you use big ints. You can also use the browser console, yes, but I like using TIO. Ah, I see you I see you mentioned that you did use bigint. Yeah, bigints are great. It's also fantastic that Python just supports them by default. It's one of the reasons that you spent 12 hours debugging. Ouch. Yeah, that's a nice thing about Python is that you get unbounded integers. It's one of the reasons that Python is so good for advent of code because you very frequently get problems that require you to use unbounded integers. And so Python having that for free is very convenient. Okay. So for this problem, I'm basically just going to solve it again. There isn't really anything I'm going to change about the approach. However, I am going to just revisit it to make things a bit more clear how exactly I approached it. So this is a reverse engineering problem because basically what we're trying to do is we're trying to figure out what this program does and manipulate the value of a such that this will output itself. So if we look through the instruction set, the instructions are 24, 12, 75, 41, 13, 55, 03, 30. I'm not going to do another generalized solution. I would invite you to just revisit my video for that. But hopefully this will maybe make the explanation of how the reverse engineering works so that you can solve this yourself without running my generalized solution code. So 2 is the BST operation, which takes the combo operand modulo 8 and writes it to the B register. And so the combo operand in this case is 4, which is the value of A. So it takes A and writes it modulo A to B. So A modulo 8 goes to B. The generalized solution didn't work. Can you send me your input? The BXL operation takes the XOR of B and the literal operand and stores the result in B. So in that case, B XOR 2 goes to B. Also, if you're not familiar with the bitwise XOR operator, basically it just converts the number to binary and then does pairwise XOR on each column of its bits. The problem statement links the Wikipedia article for it, which I think is a good resource to get an idea for what it does. It also contains information on all of the other bitwise operators, which is nice to have if you're not familiar with them. Does that not work for you? Let's see. Okay, so that's what my code says is the answer. What if I run that on day 1? I get 2416754417035530. That looks right to me. Anyway, going back to here. So, 7 is the CDV instruction, which takes the it takes the A register, it divides it by the 2 to the power of the combo operand, so that's the same as a right shift, and then writes it truncated to the C register. So we're dividing by 32 here, so A right shift 5 goes to C. And then 4 is the BXC instruction, which ignores the operand, and it takes the XOR of B and C and stores it into B. So B XOR C goes to B. And then 1 is the BXL operator, so we do B XOR 3 goes to B. 5 is the print operator, so we print out the combo operand 5, which is B, so print B. 0 is ADV, so A right shift 3 goes to A. And finally, 3 is the jump not 0 operator, so if A is not 0, jump back to start. So a couple of assumptions that I made for my solution, which as far as I know is correct, is A, there is only one ADV and the operand is 3. So in other words, there's exactly one opcode that is 0 and it has argument 3. I use the Zen browser. It's Firefox based. I've been liking it overall. It's pretty nice. So that was one assumption. Another assumption I made is that the JNZ is only at the very end to jump back to the start, and it always jumps to 0. Basically, the idea is that this entire thing should be a while A loop. The third is that the program should only output once per loop. And that's really all the assumptions that are being made here. Also that, of course, it ends with the jump not 0 loop. So given these assumptions, basically what this code is doing is each time it prints out something. I didn't make any assumptions about that, but I believe it always prints either B or C. It, to my knowledge, does not print any other values because that would mess with the reverse engineering. Other than that, it prints once per loop. This could be anywhere in this ordering, by the way. And then it right shifts A by 3, which is the same as dividing it by 8. And then it jumps back to the start if A is not 0. So what that basically is saying is while A is not 0, we are going to do something, print B, and then divide A by 3. Divide A by 8. What this is doing is because we always work with the last 3 bits of A, and we get rid of the last 3 bits of A each time, A is basically an array of numbers from 0 through 7 that we manipulate. Now, unfortunately, we cannot take each of these octets in isolation, specifically because of this step here. A right shift 5 will contain other information from the next bit of A. Now, we reverse engineer this by basically starting from the end and constructing the output. So we know that in the last cycle, we have to output a 0. What this means is that after doing all of these steps in the last cycle, B must be 0. If B is 0 here, then B must be 3 here, because the XOR operator is invertible. Basically, if A XOR B equals C, then C XOR B equals A. This is just a property of XOR. So if B XOR 3 equals new B, then new B, which is 0 XOR 3, equals old B, so B must be 3 at this point. B XOR C must equal 3, and C is equal to A right shift 5. But because this is the last bit of A, or the last octet of A, that means that A right shift 5 has to be 0. We know this is the last octet of A because if there were any later octets, then we jump back to the start and output again, which is impossible because this is supposed to be the last output. So going back, we print B, B must be 0. That means that B has to be 3 here. Since C is equal to 0, that means that B has to be 3 here. 3 XOR 0 equals 3. And since B XOR 2 equals 3, that means that B has to be equal to 1 here, which means that the last bit of A, the last octet of A has to be 0, 0, 1. We can work forward again to make sure that this is true. 0, 0, 1 mod 8 is equal to 1. 1 XOR 2 is 3. 1 right shift 5 is 0, so C becomes 0. 3 XOR 0 is 3. 3 XOR 3 is 0, and we print out a 0. And so the last 3 bits of A must be 0, 0, 1. Looking at the next bit, we see that we need to output 3. And so these bits are going to be to the left, or sorry, these are not the last 3 bits, sorry. These are actually the first 3 bits of A. Because when we right shift, we take bits off the right, so this is the leftmost 3 bits. So in order to print 3, B must be 3 at this point. So B has to be 0 at the start here. And so B XOR C must equal 3, or sorry, 0. Now what is C at this point? We have 3 bits here, so if we right shift by 5, we're going to get the 0 bit at the beginning. So C is again going to be 0 here. So B is 3, which means it's 0 here. Since C is 0, that means it's 0 here, which means it's 2 here, which means that these bits have to be 0, 1, 0, representing 2. We can test this here by seeing that A mod B is 2, 2 XOR 2 is 0. This is 10, so 10 right shift 5 is 0. 2 XOR 0 is 2. Sorry, 0 XOR 0 is 0. 0 XOR 3 is 3. And so we print out a 3. A goes from 10 to 1. And then since A is not 0, we jump back to the start and repeat that again, which we've shown will print 0. And so an input of 10 will cause it to print out 3, 0. And so we can try this just to double check our work, and we can see that this prints out 3, 0. Let's move on to the next bit then. So now we need to print out a 5. So in order to print out a 5, B must be 5 at this point, which means that it must be what is 5 XOR 3? I think it's 2. Yeah, it's 2. What this sounds like to someone who doesn't code, the insane ramblings of the deluded, I think. I'm going to drink more water. Or rather, I think it would make more grammatical sense to say the delusional ramblings of the insane. Anyway, yeah, so 5 XOR 3 is 2, so B must be 2 at this point. And now we need to look for C. So at this point, if we right shift by 5, C is going to end up equaling 2. So since C equals 2, that means that B must be 0 at this point, which means that B has to be 2 at this point, and so we again get 1, 0, 1. Let's work back forwards again. 2 gets assigned to B. B XOR 2 is now 0. A right shift 5 gives us 2. So C is 2, so 2 XOR 2 is... Oh, sorry, 0 XOR 2 is 2. 2 XOR 3 is 5, and so we print out 5. And so if we try that again, 0B, 001, 01, 0010, that's 82. If we try 82, we should get an output of 530. Nice. Apparently I don't know what I'm doing. Okay, so, sorry, let's try this again. So we're printing out 5 here. 5 XOR 3 is, no, 5 XOR 3 is 6. Opcode 7.5 is not right shift 5, but by register B. No, 7 uses the literal... No, opcode 7 is not right shift. No, sorry, it is right shift. Division by combo opera. Oh. Okay, thanks. Never mind. That might have been what I was doing wrong. Yeah, I like the reverse engineering part of this. I don't like the trying to read through the problem spec part of this because I'm not good at reading clearly. Okay, so we're trying to print out 5. And so at this point, 5 XOR 3 is equal to 6. Yeah, it's 6, not 2. I don't know why I thought it was 2. So B needs to be 6 at this point. And so we need B XOR C to be equal to 6. Now, this gets complicated because the value of C depends on B. And so reverse engineering this gets a bit tricky because we don't really know what C will be until we know what B is, and we don't know what B needs to be until we know what C is. So we can try a couple of different values here. We need this result to be 6. If B is 0, then C is equal to 2. So, or is it equal to 2? It's technically equal to the entirety of A, but we only care about the last 3 bits. Yeah, what Ya just said. It's basically B XOR C is equal to 6, and C is just a right shift B, so it's this. And I don't think there's a nice way to simplify this. Now, because there are only 8 possible values of B, we can just try them all. So if it's 0, we get 2, which doesn't work. If it's 1, we get 0, which doesn't work. If it's 2, we get 6, which does work. If it's 3, we get 1, which doesn't work. If it's 4, we get 1, which doesn't work. If it's 5, we get 7, which doesn't work. If it's 6, we get 7, which doesn't work. If it's 7, we get 7, which doesn't work. And that's all. So it must be 2. And so that means that B has to be 2 at this point, which means that it has to be 0 at this point, which means that the next 3 bits must all be 0. In other words, we basically just multiply this by 8, so we get 6, 5, 6, I think. And we see that we output the completely wrong stuff because I still don't know how to do math. Oh wait, hold on. I got one step ahead of myself. I'm still working on these bits. Shoot, that's annoying. Okay. This also gets annoying because B comes from A, which means that A is not even known, which means that C depends on B and B depends on A, but we need B to be dependent on C. Yeah, this gets annoying. The easiest way is to just check all of the possibilities, I think. Yeah, that's why I did that earlier. So anyway, if we try 80, it doesn't work. If we try 81, it doesn't work. If we try 82, it doesn't work. If we try 83, it doesn't work. If we try 84, it doesn't work. If we try 85, it doesn't work. If we try 86, it doesn't work. And 87 is our last possible option. And so 87 is what works. Yeah, okay. So that's basically as far as we can get reverse engineering by hand, because at this point it starts getting much more complicated with the circular dependencies, which is why the way I did this was to basically just check every possibility. Once we have found a possibility, we multiply it by 8 which is the same as left shifting by 3, and then try all of the new possibilities for the initial B value. So if we multiply this by 8 again, we then just trial and error all 8 possibilities. We can see that this one works. There is also, however, the possibility that because the next bit depends on what we chose this time, because the right shift will bring previous A values over to the next one, even if 697 gives us the correct answer, it might make something later down the line impossible. And that's why you have to build in backtracking. But I think that this hopefully more clearly explains the reverse engineering. Does this seem to make sense? At least the part where I did it by hand. Now I'm just going back to the whole brute force thing, but like, did deciphering this as code and then reverse engineering from here upwards by hand a couple of steps make sense? It does to the people that code. Yeah, I've been considering making coding tutorials, but there are already a lot of good ones online for people who are interested in learning to code. My videos are most certainly geared towards people who already know how to code, though. But yeah, that's basically how I mean, that's true. Maybe I'll do it. But basically, this is how I approached it. I recognized that this was going to be a reverse engineering problem because you need to figure out a value that will do what the program, that'll manipulate the program in a certain way. That's like definitionally reverse engineering. And so once I decipher into code, I see a pretty obvious pattern where it prints right shifts by 3 and then starts over again as long as it hasn't hit 0, meaning that it just looks through each block of 3 bits. And so yeah, that's exactly what I did. I used the engine from part 1, which if you look at my, what is this, day 17? If you look at my code, I basically just took this engine, but with a couple of additional assertions, and then just chucked it in the middle of a brute force loop. And so now that we figured out how we're doing our reverse engineering, we can implement it directly into an engine. And so basically we are trying to find a specific target, which is an array of outputs. ANS, or ANS, answer, is our current A value. And so basically what we do is for each initial value of B, which I've called T, we are going to attempt that, which we do by left shifting the answer by 3 and then trying all 8 possibilities. That's exactly what I was doing by hand earlier. We initialized the A, B, and C registers. Notably, B and C are written to directly and not read before they're written to at the start of each loop. And so then we just run the engine. And then if the outputted value is equal to what we're looking for, we will search one step further. And if that finds us our answer, which is once we've printed out all of the targets, then we will return the answer. So yeah, this problem is a bit complicated to explain, but hopefully it has relatively made sense. All right. Next up is problem 18, which I did want to explore here. So 18, for part 2, it was basically what is the first byte that will cut off the path to the exit? Basically, we have a sequence of walls, and we're trying to figure out if we add these walls one by one, what is the first point at which the set becomes disconnected? Now, the way I did this was kind of overcomplicated. The way I did this problem was using a binary search. Basically, what I did was, given a number n, we can determine if the graph is still connected or not by looking at the first n coordinates, dropping them onto the grid, and then trying to pathfind from the start to the end. And basically what we'll observe is that as we add more walls, the connectivity of the graph will go from being true initially to at some point abruptly false. We're trying to figure out where this is, and so we can just binary search. Basically, we know that at the beginning the first is going to be connected and the last is going to be disconnected. And so then we pick a point in the middle and search that point. If it's disconnected, that means that we're too far right, which means we look at the left half and repeat our search. And then we go by half again. If we find that this position is connected, that means that we are too far left, and so we bisect our result again. Standard issue binary search. Now, unfortunately, this is kind of overcomplicated. First of all, one of my subscribers said that you can do this in a linear search. Now, they used Rust, to be fair, which is a lot faster than Python, and I don't think linear search would take a reasonable amount of time. But I also did run into a one-off and lose a minute to the timeout, so it probably would have been better to just use linear search. One of my friends on Discord Rage League did present an interesting solution to this problem, though, which was to do a linear search with disjoint set union. I'm going to introduce this one partly just so I can introduce what disjoint set union is. So disjoint set union is, it kind of says in the name what it does. It's the process of taking the union of disjoint sets. So disjoint means no intersection, which means that a set of disjoint sets is a set of objects that do not overlap. Basically, if we have a bunch of objects, taking the disjoint set, or having disjoint set, means that the objects are grouped into sets in a way such that none of the sets contain this, no two sets contain the same item. So for example, this would not be disjoint sets because there would be overlap on these two elements, but this would be a way of representing disjoint sets. And now what's commonly needed for disjoint sets is to be able to merge two of them together. And that is what disjoint set union is. It's the process of taking the union of disjoint sets and merging them together. This is commonly used in Kruskal's algorithm, which is an algorithm for finding a minimum spanning forest of a graph. So what on earth does that mean? Let's suppose we have some graph of elements that looks something like this, for example, and let's suppose that they have edge weights, and we want to find what is the let me add a couple more edges just to make things more interesting. What is the tree with the minimum sum of edge costs that spans the graph? So minimum spanning forest is a more generalized version where if the graph is disconnected, we'll find a forest. A forest is just a collection of trees because mathematicians like being funny with their naming. The more specific form, when we assume that the graph begins connected, is the minimum spanning tree. A spanning tree is a tree that covers all of the vertices in the graph, and a minimum spanning tree is the spanning tree with the least number of, the lowest sum of edge weights. Hi, Yuvraj. And so in this case, we want to find a spanning tree that has the least total cost. So for example, that would look something like this. This would be a minimum spanning tree. We observe that this edge is too expensive to be worth using. We connect these using the ones. These two edges are also a bit expensive. So that would be a minimum spanning tree, unless I'm wrong and missed something. Satya, I'm not entirely sure. It's not technically in my plans to do any postgrad, but honestly, I'm not sure because most of my job experience is in web dev, and I'm not really sure I want to do web dev. It pays well, but it's also like really boring and unfulfilling. So I might do a master's or possibly look into going further than that and going more into research. But I'm not sure yet. But yeah, for Kruskal's algorithm, what we do is we initialize a disjoint set where each point begins in its own set. And so we have 7 disjoint sets here. And we are going to perform disjoint set union. What kind of research? Probably cybersecurity. Cybersecurity is something that's interested me for a while. And I don't know. It seems like it could be something that's interesting, but based. Cybersec mention. See, we have some cybersecurity fans in the chat. Anyway, so basically what Kruskal does is it takes all of the edges and sorts them. Then for each edge, if the 2 points that it joins are not in the same set, that means that it is a new edge that is not going to form a cycle, and we can add it to the tree. So let's go through this. This is an edge with lowest cost. It has cost 1. These two sets are not these two vertices are not in the same set, so we're going to add this edge to the tree, and then we are going to merge the 2 sets together. Now we can look at this edge, for example. since these two vertices are not in the same set, we can add this edge to the tree and then merge these two sets together. Looking at this one, these two vertices are also in distinct sets, so we can merge them together and add this edge to the tree. You can do a lot of reverse engineering in cybersecurity, and that's one of the things that interests me about it. Also, experience in web development is honestly not entirely irrelevant to cybersecurity. I don't have much cybersecurity experience, but I do really enjoy problem solving, and honestly, web dev doesn't have enough of that for me, which is why I kind of want to do cybersec, because cybersec has a lot more puzzle-like stuff in my experience, or from my knowledge rather. I don't have experience, that's the point. But I think having web dev experience is not entirely irrelevant to cybersecurity, because a lot of stuff involves like reverse engineering, like vulnerable websites and stuff, and having both front-end and back-end web dev experience is helpful with understanding the weaknesses. I can do CTFs, and someone in my school is planning on starting a CTF club, which is something that I'm definitely going to join and look into doing. Anyway, looking at the next available edge, these two vertices are also not in the same set, so we can merge these sets together and add this edge to the tree. And now we can look at this edge. So this edge connects two vertices that are in the same set, so we skip it. This edge does not, so we now connect these together, and we have to merge those two sets, which grabs all of these nodes together. And finally, we look at this, which doesn't connect two edges in the same set, and that completes our minimum spanning tree. So it appears that I was correct about my initial guess as to what the MST was. Okay. So that is an explanation of Kruskal's algorithm, which uses disjoint set union. And you can see here that we repeatedly checked, are these in the same set? And if not, we'll add the edge and merge them. So those are the operations that are used for disjoint sets. The first is to check which set a node is in. The second is to be able to merge two sets together. Now, there are several ways you could go about implementing this, but the one that I see used most often, and I think the one that's like the best algorithmically speaking, is to represent each set as a tree. So, a set is represented as a tree where it is identified by its root node. So initially, let's suppose we have 7 disjoint sets. So, these are our 7 nodes. But what the hell is a tree? Okay, good point. Here I'm not referring to a tree as a graph, I'm referring to a tree as a data structure. A tree, in terms of a data structure, is a node that has some value and has some number of children. And so a tree, the tree data structure, is represented as having some value and having a number of references to other tree nodes. So it has subnodes which can each have their own subnodes. I'm not living that one down. Yeah, there are a lot of interesting quotes I've said that I'm not going to live down. Anyway, so if we represent each set as a tree wherein each node is initially its own set, then we can query a node by taking a look at it and going back to its root. So initially, that would be itself. Now let's try merging two sets. Let's try merging set 1 and set 4 together. What we can do is we can put them into the same tree, so we can pick up one of the trees and make it a child of the other tree. That's what we have now. Weakest RB tree enjoyer is greater than strongest hash map user. I forget what red-black trees are, honestly. I learned about this a couple years ago in one of my CS courses, and I totally forget what a red-black tree is. It's that data structure where like red nodes can have any child, but black nodes can only have black children, right? I'm aware that sounds racist. Um, a red-black tree is a self-balancing binary search tree data structure. They have an extra color bit to ensure appropriate balance. It's a special order 4 case of a B tree. What is it? It's a binary search tree where the leaf nodes are empty. And yeah, they really did not need to pick black as one of the colors. Like, they could have made it like a red-blue tree or something, and it would sound much less racist. Like, what is this? The black depth of a node is defined as the number of black nodes from the root to that node, i.e. the number of black ancestors. Why? Okay. Every node must be red or black. All null nodes are considered black, and red nodes do not have red children. Okay, I got it the wrong way around. Red nodes must have black children. Black nodes can have either red or black children. Yeah, this sounds so wrong to say. Like, why? Why'd they have to pick these colors? At least it's not a white-black tree, because that would sound like even worse. Otherwise, memes wouldn't exist. You know what? Fair enough. Yeah, that would have made this so much worse. Anyway, that's not what I'm using here. But anyway, so now that we have this data structure, what this is telling us is that 1 and 4 are now in the same set. So if we try to figure out what set 1 is in, it's still just 1. If we try to figure out what set 4 is in, we will look at its root, which is 1 in this case. And so 4 would be in the set identified by 1. And so in this tree, rather than taking each node and storing a reference to each of its children, we're actually going to do the exact opposite of what I said earlier, and we're going to take each child and store a reference to its parent. Because the parents don't care about their kids in this setting, but the kids do care about who their parent is. Because we only need to trace upwards. Now let's say we want to merge the set containing 3 and the set containing 5. So we're going to pick up one of those, and we're going to move them under the other. So now 3 is now a child of 5, which means that if we try to get which set 3 is in, we will look at its root and get 5. Now let's say we want to merge the set containing 3 with the set containing 4. Well, we can't just pick up 3 and move it because 3 is attached to 5. So we're going to trace 3 up to its root and find the root of 3, which is 5, and we're going to pick that up and put it under the root of 4. So now we're going to get this. So now these two sets are unionized. So the children are unionizing. Put that on the quotes too. And so now we can see that if we want to grab either 3, 5, 4, or 1, all of them are in the tree with the root of 1. And so the way we find the root, I will explain path compression. If we want to figure out which set 3 is in, we'll look at its parent, which is 5, and then we'll look at 5's parent, which is 1. And since 1 does not have a parent, it is the root of the tree. And so union find set, yes, that is what I'm doing, I think. I don't remember the name of stuff like this. That means that 3 is in the set identified by the node 1. Okay, so now we get to two interesting optimizations, one of which is completely irrelevant and the other of which is extremely important to implement. The first one is noting that the deeper your tree is, or the taller your tree is, the more inefficient because you need to trace up more routes. And so if you have one tree that is extremely tall and one tree that is relatively short, you want to move the short tree underneath the tall tree so that the total depth is still, the total max depth is not increased. if you were to pick up the long tree and move it under the short tree, because the node would end up here, your total depth would end up 1 greater, which is bad. This is completely irrelevant and not worth your time implementing. The other one is path compression, and if you don't implement path compression, you are trolling, basically. So we notice that 3 is within the set defined by 1. But do we really need to look through 5? As with most things, we want to cut out the middleman. This applies to economics as well. And so what we can notice is that we can just move 3 directly under 1. This would have the same result. And so each time, 3 could also have its own children, for example, and so this would optimize even more because these children no longer need to go through 5. So what we notice is each time we query a node and find its root, if it is not a direct child of its root, we can make it a direct child of its root because we don't care about its lineage, we just care about who its oldest ancestor is. So now 3 is directly a child of 1. Don't think about the implications of changing family trees like this, okay? And so this is called path compression because basically we have taken a path that goes up to the root and we have compressed it into one edge. This means that the next time we look at 3 or any of its descendants, we will save the amount of times we need to recurse by however many paths we cut out in the middle. And so that is path compression. Path compression is extremely important because if you don't do path compression, your code will get very inefficient and your tree will end up really deep. This is also why the other thing does not matter. The other thing saves like 1 depth, but if you do path compression, you're going to fix that problem anyway. So path compression is very important, and this is how we're going to implement this. Now, how does this relate to the problem at hand? I have not explained why any of this is even relevant, but before I do that, I'm going to get up to stretch again and also go use the washroom. So y'all should also go take a break, touch some grass, drink some water, and I'll see you back in a couple of minutes. Why not start with the root node having a bunch of children that don't have their own children? What do you mean? Because the root node is what identifies the set. And so, wait, like you mean initialize the tree as some root that's unlabeled and then have each of the nodes as a child or something like that? Like do the path compression, we add them to the tree instead of when you query. Because you don't want to, okay. Premature optimization is generally speaking something you should try to avoid because you're going to end up wasting more time doing unnecessary operations. If we merge 2 sets and then don't actually end up querying any of these, spending the time moving all of them underneath the root is going to waste more time than it would save. We only really need to care about that each time we actually query, because doing it all in advance and doing it at query time is going to end up costing the same number of operations if you query everything. But if you don't query everything, then prematurely optimizing here is going to end up costing you extra operations, moving stuff around that wouldn't end up being checked anyway. Anyway, I will see you back in a bit. I think slow mode is back or off. I have freed the chat. Yeah, no, Pat, I don't think you are able to do that. I changed that from YT Studio. Actually, you might be able to since you're a channel manager, but I'm not sure. Okay, where were we? Right. So, searching through going forward to see at which point it breaks is not going to work with disjoint sets because we cannot determine when we remove an edge whether or not it will disconnect things. However, we can search backwards starting from the end with a disconnected graph, and then each time we re-add an edge, we can see if it reconnects things. Code Golf is how a lot of people are in my community. I should do more Code Golf related stuff. Anyway, so basically what we're going to do here is we're going to start from the very end when all of the walls have been placed, and we're going to get a disjoint set of nodes such that each set represents a list of connected points, and then we're going to remove the walls one by one and add them as edges, and each time we do so, we are going to merge the disjoint sets. This is also going to, there is also something notable here, which is that whenever you whenever you remove a wall, you add both an edge and a node, because the node also gets unwallified, and so it gets re-added to the graph. And so each time you do a DSU, you are also going to add a new node into your disjoint set. And this is important because you might later connect something to that. What I mean by that is, for example, if we imagine we have this situation, then currently this is a set, this is a set, and this is a set. When we remove this edge, then not only do we need to connect these sets, but we also need to add this as a node to this overall set, because if we then later remove these walls, then this needs to be able to connect to this set here. And so we do need to add the walls as nodes when we drop them. So let's now grab our input. So what is this, day 18? We are going to take our coordinates and initialize our disjoint set. What is S? S is 70, which is... What the hell is 70? Oh, 70 is the size of the grid. Right. Yeah, S is the size of the grid. This is what I get for naming my variables poorly, but oh well. Yeah, so range from 0 to 70. So technically the size of the grid is 71. The coordinates range from 0 to 70. So the grid is going to be how do I want to represent this best? I think what I'm going to do here is store the coordinates as a set. Yeah, so now that we have a set of tuples as the coordinates, and now we're just going to form the disjoint sets by going through each of the possible coordinates. So we're also going to initialize a scene set. Sorry, this actually does have to be a list initially, and then we're going to make a set of chords. This has to be a list because we have to be able to remove them in order. And so now we're going to do for blank in range s plus 1, or sorry, for r in range s plus 1, for c in range s plus 1. this will loop through each of the coordinates in the grid. And now we're going to say if it's in scene, if RC in scene, we're going to skip it. We can actually initialize scene to the same set, actually. And now what we're going to do is, if we have arrived at a new node that is not already part of a different disjoint set, then we can add it to a disjoint set. So remember what I said about disjoint sets. Parents do not care about their children. And so we're going to store our tree as a map from each child to its parent. So parent is initially going to be a map. Now, MathCat mentioned something earlier. There are two ways of representing roots. You can either represent the root of a node, you can either represent a root as a node with no parent or a root that is its own parent. It really doesn't make that much of a difference. It just depends on your implementation details. And one other notable thing is that instead of being a map, the parent can be an array usually, because if you have n nodes, then rather than being a map, you can make it an array of size n, and arrays are a bit more efficient than maps. So let's actually do that. In this case, since we're working on a 2D grid, it makes sense for the parent map to be a grid. So it's going to initially be none times s plus 1 for blank in range s plus 1. So now it is a grid with coordinates spanning from 0 through s, which is 70 for the main input. And we're going to interpret none as this root is a node. So now what we can do is we're going to begin by, we're going to do this very similarly to how I did the previous related problem, the tree problem, where we're going to have a search set, which is initially going to contain RC. There you go. Okay, so we're initially going to have a search set which is RC, and we're also going to add it to the scene set. And now we're going to look at each of its neighbors. So the parent is, we're going to, since we're initializing a entire set, what we can do is we can just make all of them children of the node from which we started. We're not going to make it the child of the previous node. We're going to initialize by flattening all of our paths. So the parent of RC is going to be itself, so we can just keep that as none. And now what we're going to do is for each item we're searching, so for while search, RC equals search.pop. Also note that this variable shadowing does not matter, because when you do a for x in a y loop, x gets reset each time, so this shadowing is fine. Also, you'll see why I'm doing this in a bit. I'm actually going to change this from what I said earlier. I'm actually going to represent a root as having itself as a parent. So now each time we pop off a new item we're searching, this is an item that belongs in the set. And so we're going to add it, we're going to set its parent equal to the root. And this is where I realized that I do actually need to preserve the variables. We're going to initialize, we're going to set the parent of CRCC to RC. Now note that the first item we search is going to be RC itself, so it's going to set itself as its own parent, which is why I've chosen this interpretation. And now we're going to look at all of its potential neighbors. In this case, because we cannot diagonally step through walls, we are going to only look at edge neighbors instead of the entire corner neighborhood. So we're going to say for neighboring row and neighboring column in you've seen me type this like 700 times by now. And then we're going to take a look at each of its neighbors. So the neighbor cannot be in the scene set, although if the neighbor is in the scene set, then we've done something terribly wrong unless it's in the wall set. So it will never be in the scene set, because if it's in the scene set but not the wall set, what that means is that we have encountered a coordinate that was found in a previous iteration that is adjacent to a node that was not. And that is impossible because adjacency is bidirectional. And so that should never be the case. And so we don't need to check the scene set, we only need to check the wall set. Which actually makes me realize that we can initialize the scene set to be empty. So if it is in the wall set, or hold on. Yeah, if it's in the wall set, so if nr and c is in c set, then that means that it is in a wall, and so we cannot step into it, so we're going to skip it. Additionally, if it's out of bounds of the grid, then we also want to skip it. So if nr less than 0, or nc less than 0, or nr greater than or equal to s, or nc greater than or equal to s, then we also want to skip it. This also makes me realize that the scene set isn't redundant. The scene set is actually needed. So if we are stepping into this neighbor cell, then we need to do a couple things. Firstly, we need to add it to the search set so that we can recursively or iteratively search its neighbors. I do like keeping my nesting levels small, yes, because deep nesting tends to get confusing. And then we also need to add it to the scene set so that we don't try to search it later, because that will cause us to loop unnecessary amounts of times, and that will introduce inefficiencies. So this should theoretically work now. And because I said that, it won't. It is hanging. Why is it hanging? Oh, because I'm a fool and search is going around in circles, because I actually do need to check if it's in the scene set. Because otherwise within the same iteration I'm going to keep going around in circles. Okay. Now that works because I've stopped being a fool. So, for the sake of example, let's first look at the example situation. So, if we set s equal to 7 initially, then this is what we begin with. So let's interpret what exactly this means. So let's first draw out this grid. So for r in range s, for c in range s, print end equals pound if rc in chords, else dot print exit 0. Okay, so this is what the grid initially looks like. And as a reminder, we're trying to get from the... Where are we trying to do? We're trying to get from the top left corner, 0, 0, to the bottom right corner, which is the maximum coordinates. So that's what the grid looks like. And this is what the output from our code looks like. So looking at these 4 values, they have parents of 0, 0. What that's telling us is that the first 4 values are all part of the set identified by 0, 0. This makes sense because we hit the topmost and then leftmost corner of each set first because of our iteration order. And so that tells us that these 4 were all identified as belonging to this set, which is indeed correct. Let's format this a bit better. There we go. And now these 3 are walls, so they should be represented as being their own parents, which they indeed are. And then these 3 are walls, so same thing. And then this element is again 0, 0 because it belongs to this set. And we can see that this set is connected all the way down to the bottom left. And you can see that our algorithm correctly identified all of these as connected to 0, 0. In this case, there are only two disjoint sets. The second one is identified by the coordinate 3, 4, which is this one. And we can see that the 3, 4 set contains all of these elements in this squiggle shape followed by a drop, or I guess it's like a playground slide shape, like so. Okay. And so we can see that indeed we have correctly formatted our grid. And so if we go back to our standard, our normal output, we can see that this is our parent map for our disjoint sets. Also, just as an aside, I realized that I technically blundered here. You can make the parent just none, because you could also just move this to here. And so it kind of does the same thing. Because then instead of setting the parent at the search at the beginning of the search step, we set it when we add the node to the search set, which is the same thing except for the one element that starts in the search set initially. So if we do that, we can see that a lot of nodes will now have none as a parent. It doesn't really make much of a difference, but technically it simplifies the code by a tiny amount. So finally, let's piece this together. Each time we are going to remove the last coordinate. So we're going to say, what are we trying to get? We're trying to determine the answer as the coordinates of the first byte that prevents the exit. That is to say, it's the last byte that didn't restore the exit from being reachable. And so we're going to say for wall row wall column in chords reversed pass, and we're going to keep track of the last blocking chords as initially none. Each time what we're going to do is we're going to see if this restores the exit, and if not, we're going to set last blocking chords to WRWC, and then at the end we will print out last blocking chords. Or I guess you could do this. We're going to do that. And so if we run it right now, it'll just give us the first coordinates, which is 67, 67. And so now we just need to check this. If restoring this wall returns the if restoring the path through WRWC restores access to the exit, then we want to exit the loop and print out the last coordinates that were still blocking the exit. Basically, what we are doing is instead of searching for the first place where the exit is disconnected, we're going backwards and searching for the first place where the exit is reconnected and then taking the last one before it. That's the same answer, of course. And so now we are going to implement our disjoint set union. So remember what I said about disjoint sets? We need two operations. The first one is to figure out which set a node is in, and the second is to figure out, or the second is to union two sets. So let's make two functions for that. The first is going to be define find. Oh yeah, I think this is called union find because the two operations are union and find. Okay, so find is going to obtain which set a node is in. So find, given a row and column coordinate, is going to check if it's the root. So if it is a root node, then we're going to return RC directly. And otherwise, we are going to recurse upwards. We're going to parent is a bad name for this. What should I call it? Like parent grid? Yeah, parent grid. So the parent of RC is going to equal parent grid at RC. If the parent is none, that means that it is an orphan, and so it is the root. And otherwise, we're going to recurse upwards. So parent is going to be a pair, which parent is going to be a pair, and since find takes 2 arguments, we're going to return find star parent. The star operator just takes each item in an iterable and dumps them into a function as individual arguments. So this given RC will tell us the root of its tree, which we said is how we're going to identify a set. Also, this is where we're going to do our path compression step. Basically, as we go upwards, we're going to compress our path. Also notice something else that I totally forgot to mention, but if we have a bunch of nodes in a lineage up to the root, when we start here and then search up, we're going to put this directly under the root to compress the path. But what we can also do is, because we needed to go through this node to find the parent, we recursed onto this node, which means that we can also put this node directly under the parent. And so as we trace up the path to a parent, or up to a root, what we're going to do is we're going to compress all of the paths and put all of them directly under the parent, because that way the next time we need to look for any of them, we only need to recurse once. And so we're going to do parent grid RC equals find parent, return parent grid. And so what this is going to do is when we recurse upwards, we're going to find which tree this belongs to and put it directly underneath the root and then return. When we recurse, this is going to run for each step along the way, and so we're going to compress the entire path and merge all of them under the parent. Do note that this technically is redundant for the direct child, but it doesn't really matter. And finally, the second step is to union. So union takes the R1, C1, R2, C2, and we'll merge those two together. So we'll say R1, C1 equals find R1, C1, and same for R2, C2, because we can only union the sets once we know their roots. And once we know the root of the two trees, we will just move one of them under the other. Which one do we put under the other? Well, technically it is optimal to put the shorter tree under the taller tree, but then you need to figure out which tree is taller. And like I said, no one cares. So we're just going to arbitrarily pick one. We're going to move R2C2 under R1C1. And so now what we've done here is we've moved the root of the second set to underneath the root of the first set, which means that they now belong to the same tree, which means that when we look for anything in the second set, we're now going to get the first set as its parent, meaning the two are now unionized. So what we're going to do here is each time we restore a path, we're going to union the two sets, or rather we're going to union all of the sets that are connected to it. So let me think about how we're going to do this. First, we're going to remove the wall from the chord set. I guess this would make more sense to call W set, but whatever. W set for wall set, I suppose. Sure, that works with me. Okay. Also, sorry, I get distracted very easily, but just as a brief interjection, there are two functions for deleting items from sets. There's .remove and .discard. .remove will error if the item is not in the set. .discard will just silently ignore it. That's the difference. Anyway, just randomly thought of that. So now we remove this wall, and so we might end up unioning more than one or more than two sets, because when we restore a wall, we have theoretically up to 4 sets that could be connected to this wall here. And so when we delete this wall, yeah, just that doesn't work unless wset is a map, which it isn't. Unless that does work. No, that doesn't work because sets don't support item deletion. But yeah, this might connect, once this is removed, it could union up to 4 different sets plus itself. So when we remove the wall, what we're going to do is we're going to look at each of its neighbors and see if it belongs to a set. So for what we're going to do is we're going to union all of the sets to WRWC itself. So for neighbor row, neighbor column in, you are now seeing me type this for the 701st time. For each neighboring cell, if it is not a wall, because if it is a wall, then we don't actually want to union it yet. First, it needs to not be out of bounds. So if nr less than 0 or nc less than 0 or nr greater than or equal to s or nc is greater than or equal to s, we're going to skip it. And if it's a wall, then we're also going to skip it. I really need to just set up like a library for myself. Like, I shouldn't be typing all of this for the 8 billionth time in like the AOC solve. It costs a decent amount of time to have to type that all out. At this point, I really need to just make a function. I had a library function in the past, but I stopped using it. I'm going to continue not using it during my videos because I want them to be self-contained, but at this point, I feel like I should probably make some amount of preparation. Okay, so if it's not out of bounds and it's not a wall, that means that we have a set that we might need to unionize. Now, notably, if we call union on two things that are the same, so this is the root of the two sets, this will technically break things if we union a set with itself, because if we set something to its own parent, then it's going to loop indefinitely, because this condition will never be met. So if R1 RC, or if R1 C1 equals R2 C2, then we can just skip the union step. Vim macros. I don't use anything more complex than like insert and copy paste in Vim. I know embarrassingly little about how to use Vim, actually. Like I said, I'm extremely basic in terms of being a programmer. I barely use Linux. I barely use Vim. Yeah. Anyway, if we have found a set that we potentially need to unionize, we're going to call the union function on it. So we're going to union WRWC with NRNC. And finally, we just need to check if that connects the two coordinates. So the coordinates that we're looking for are 0, 0 and s minus 1, s minus 1. Yeah, just remember when you said you wanted to change s to 71 so that you could stop writing +1? Well, now you get to write -1. And you also have to deal with the greater than or equal to sign here. So it didn't end up actually saving much. So now we're going to check if the top left and bottom right corners are in the same set. If they are in the same set, that means that they have been unioned together, which means that they are now connected. So if the set containing 0, 0 is equal to the set containing s minus 1, s minus 1, then we are going to exit, because this means that the start and the exit have now been connected. Now, how much you want to bet that this isn't going to give the right answer? Yeah, it didn't give the right answer. Group debugging session part 3. Stream on Twitch and do predictions. That would be pretty funny. My answer is 1 off. Is this... Oh, it's the 4th group debugging? Okay. Why do I have a 1 off? When I remove this wall... Oh. I get it. Yeah, okay. I It's not because of 7071, yeah, just you're fine. That would not be the problem because I adjusted for all of this. No, the problem is I'm supposed to find this coordinate, right? So when we search backwards, if we remove a coordinate and it causes the graph to become connected, that means that that wall was the one that was blocking us, correct? So I one-offed myself by forgetting that we are actually looking for the phase transition going up, and we're looking for the beginning of it, which, because we're looking backwards, is the end of it. So the last blocking coordinate is actually the one that restores the connection, because it means that when it was placed in forward time order, it's the one that blocked us. So we actually want to print out this one. And not the last one, because the last one is this one, which didn't change the phase. The one that does change the phase is actually the correct one. So yeah, I trolled myself. Anyway, this solution ends up being instant and is much more clever than the binary search approach. It is technically a bit more complicated, but like if you have DSU utilities or are faster at thinking than I am, this could end up being a more reasonable solution than binary search, especially since binary search is very prone to one-off errors as well. Anyway, how does this end up comparing to my original solution? My original was 38 lines. This one is 50 lines. So it is a bit longer. Although this is honestly not all that simple either. It does require you to do BFS, so it really just depends on what you're more familiar with, I guess. I think it is faster, though. No, they're both instant. Never mind. Well, at the very least, we got to learn about DSU together. Pat, have you been keeping track of how long I spent on that problem? Because I think I spent like an hour explaining DSU. It really shouldn't take that long to explain, but I talk a lot. Okay. Well, that was day 18. This was a solution that one of my friends showed me. They explained this to me, I think in person, so it's probably not on the Discord server anyway. But yeah, basically, instead of using a binary search or a direct linear search, you can look backwards and find the first wall that, when removed, rejoins the connection, which allows you to use DSU, which is a very clever way of doing this. This is also technically more time efficient, but in this problem scope, it doesn't really matter too much because the efficiency doesn't end up being a concern. Problem 19. There wasn't really anything that I wanted to revisit here. This problem was relatively standard as far as algorithms go. For part 1 and part 2, both of them were really just memoized recursion. Really not that interesting of a problem. Day 20. Day 20, I do want to make note of one specific thing. XSDev commented that I have a bug with the original code I uploaded, which I fixed in another commit. But basically, the issue that I was encountering is that I had accidentally made a copy-paste issue and written rows where I meant columns. Now, this doesn't cause issues if your grid is square, and I believe the grid is square, but I did make a typo. And it is now fixed. There is also an efficiency thing that you can do here. So let's revisit this. This is thanks to FLWI and logical errors on... sure, I'll put up a timer. So The idea behind this problem, recall that basically the idea is you can cheat by going through walls for a couple of seconds. So for part 1, it doesn't really matter too much, but for part 2, what I did that was particularly inefficient was, because we can make a cheat of up to 20 picoseconds, what I did was I looked at every single grid position within 20 Manhattan distance of the coordinate at which we decided to start cheating. Now, this is quite inefficient. All you really need to do is look at all path coordinates after a certain point and try to find if any of them are in range. So I think it is specified here that there is only one path, right? There's only a single path from the start to the end, and all of the programs go at the same speed. Does that mean there are no branches? I think so. Yeah, so there's only one path, and what that means is that when you start a cheat, instead of looking at all grid positions within that position, which is comparatively inefficient, you can just look at all positions in the path that would save time. So remember that it only saves time if it is a certain amount of time ahead. So if I look at my day 20 code initially, you can see here, let me copy over the input first. You can see here that basically for each position, I looked at if I could initiate a cheat there. And what was it? What is the answer? How many cheats save you at least 100 picoseconds? Yeah, so distances was basically the distance along the path. So for example, the first item on the path is 0 and everything else on the path is how far it is from the start of the path. So the distance from where we are to where we end our cheat must be at least 100 plus how long we spent cheating, because this does not count as time saved, so we need to save at least 100 picoseconds. But notably, going through every single item within 20 radius is very slow and very inefficient. What we can instead do is, for each coordinate along the path, we can just look at all coordinates further on in the path. So we're going to store the path as an array that begins at RC, and each time we add a new item into the path, we're going to do path.append and our NC. So now if we print out our path, let's grab our test input. Where is it? Where is the test? There it is. So if we grab the test and then we output the path, we see that this is what we get. We begin at coordinate 3, 1, then we go up to 2, 1, 1, 1, then we go across to 1, 2, 1, 3, down to 2, 3, 3, 3, across to 3, 4, 3, 5, up to 2, 5, 1, 5, and then so on and so forth. And so now we have a list representing our path. We can also go back and, sorry, we don't want to go back. So now what we notice is that we don't need to scan through every single item in the grid. Instead, we can just loop through the path. So for RC in path, we're going to look at all of the cheats that can start from that position. Now we also want the index of the path, and you'll see, or the index of this, and you'll see why in a second. But we're going to use the enumerate function for this, which takes an iterable and returns a new iterable, which is a pair of the index and the element at that index. So now what we are doing is noting that instead of looking for every position within 20 radius, we just need to look at everything further along in the path that we could cheat to. So for NR and C in everything that we can cheat to, which is everything further on in the path, and then we're going to do roughly the same logic. So firstly, this needs to be within Manhattan distance. So the radius needs to be at most 20. The Manhattan distance is just the absolute distance between the rows plus the absolute distance between the columns. So if abs r minus nr plus absolute value of c minus nc is greater than 20, we're going to skip it, which means that this point in the path is too far away for us to cheat to. And then we're also going to see if it actually saves us time. So if now we no longer need to use the distances thing because we can instead just use the path index. So I think this actually no longer is needed at all. Is it no longer needed? I believe it's no longer needed. If nr and c equals path -1. Continue. Yeah, okay. So just to briefly explain what I'm doing here. Previously, distances was used to represent the distance from each node to the start of the path. And so if the distance is not -1, that means that we've already visited that node. This just prevents us from backtracking. By deleting distances, we can save a bit of memory. And in order to avoid backtracking, we can just make sure that we're not stepping back to the spot we previously stepped on. Because there are no loops, we only need to prevent stepping backwards in the same direction we came from. So this suffices. This prevents us from running into walls, this prevents us from backtracking, and once we found the appropriate node, we just continue forward. So now to get the distance between RC and NRNC, all we need to do is figure out what the difference in the index is. So again, we can use enumerate. And what we are now doing is J is the index in the future path. So when j is equal to 0, that means that this item is one further in the path. So the distance that we have moved from RC to NRNC is equal to j plus 1. And so what we can do here is if j plus 1 is greater than or equal to 100 plus the radius, we can increase the count by 1. Something else that we can notice is that the radius can never be negative, and so j has to be at least 99 for this to ever be possible, except since radius can also not be 0, j in practice has to be at least 100. So what we can do is we can advance the path by 100. Basically, we're not even going to search for anything within 100 of ourselves because that's obviously not going to be more than 100 of a time save. And then we're just going to subtract 100 from the requirement. How much do you bet this doesn't work? We're going to get group debugging session number 5, by the way. Does this even save any time? I'll be very sad if this actually ends up being slower, because this is an optimization that several people mentioned to me in my comments. The problem... Wait, this isn't even being hit. It's not even this that's freezing. Did my backtracking fail? My backtracking failed, didn't it? The line 26 exit 0 should be getting hit. I am very confused why this is not working. Because RC should be the last item in the path. Which means that the previous item that we want to avoid backtracking to is the second last one. But we're clearly backtracking here. like if I run this, you can see that it just loops indefinitely between two valleys. The input is still the test input, so this shouldn't be slow. Why is it jumping around? Why is it jumping between 1, 1 and 1, 2? From 1, 2, you can go to 1, 1, but that should be covered by the backtracking step. All right, screw it. There's another way we can do this. Whenever we leave a cell, or whenever we arrive at a cell, we can just set it to a wall so that we can't revisit it again. This is not a great way of doing this, but it works, I think. Yeah, this technically works. Okay. Yeah, so this technically is a way that works. Also, we do need to include the end step in the path. So we do need to say path.append RC once we've arrived at the end. Nope, never mind. That's already done. My bad. Satya, I tried path -1, but that wasn't working the first time. So I'm kind of confused why that wasn't working, honestly. Yeah, what happens if we do print out the path? I'm going to take a detour to check what Luke said. One, 1, 2, 1. That's not even valid. How's it going from 2, 1 to 1, 2? Oh, it's because it's not breaking. Like, I don't have a break statement here. No, that doesn't make sense either. There should only be 2 things that can be visited, one of which should be the one that we are not allowed to revisit. Oh, I get it. I get it now. I get it. What I'm doing here is I'm saying, let's suppose we're here and we came from this side and this is our next available cell. If we loop through each of these in this order, what's happening is that we're checking this one. We're seeing, okay, it is not the last item in the path, so we're going to add it to the path. And then when we check this one, is not the last item in the path because the last item in the path has been updated to here. So this also gets added. I was trying to avoid the whole inefficiency issue of checking if NRNC is in the path at all, but I ended up messing myself up. If we search it in this order instead, it would be fine. But since we're searching in this order, it ends up not being fine. Anyway. This is technically a more elegant way to do it. If NR and C in scene continue, otherwise add it to the scene set. This is technically a more optimal, or this is technically a better way of doing it, but we can notice that we're already doing a wall check, and so instead we can just set it to a wall. Or rather, this should go here. So in order to avoid backtracking, we can just set each cell that we visit to a wall, which prevents us from going back to it. Okay, and now this works. And so now we can go into the group debugging session because there's surely no way this works. We can remove the scene set. Yes, thank you. This is also still very slow. I will be very okay, this actually gave the correct answer. I'm surprised. Now, how does the timing compare? Let me first make sure I don't lose this code. Timing day 20p2.py. Okay, let's time this. Okay, that takes 15 seconds. Now, what if we use the old code? Surely this is a time save, right? It's gotta be. I keep clearing my clipboard because I just don't like having... Okay, it's not even a time save. I just don't like having too much stuff on my clipboard. I don't know why I keep clearing it. Well, chat, it looks like that actually didn't... Wait, hold on. I pasted the same code back. I forgot, I copied from the wrong file. So it takes somewhere between 14 and 15 seconds. And this is the actual old code. I pasted the wrong thing. This is faster. I saved to negative 10 seconds. What's this problem called? RAM run? It's not what I want. Nope. Race condition. I swear it's the... How many items are in the path anyway? What is the length of the path? There has to be a way that this is more efficient. The path is 9,465. Maybe that's the problem. It's because we're looping through too many items to look for cheats. What? I'm thoroughly confused. I don't think I'm supposed to use quad trees here. Surely I don't need to pull out the quad trees, right? I don't feel like doing quad trees today. I also don't think that'll be faster even. Satya knows what I'm talking about. We need to watch the Himalayas video on the right. Man lost in the Himalayas tells horrifying story from Scary Interesting. No, I don't feel like becoming a reaction streamer. Okay, I might have just misjudged. I spent 20 minutes saving negative 10 seconds. Are you kidding me? That is really funny. Except for the fact that it's not, but like this is exactly what some people said had saved them time. I don't know. Maybe I trolled myself. Oh well. And unlike the last day, unlike the last one we did with the DSU, we can't even say that this one like taught us anything. Cuz nothing really there's nothing really to learn here. What would I pre-compute though? Prefix sum? How? I don't think that works here. I mean, the different like you have to check every possibility and then look like basically you're looking for the you can remove line 41. I mean, yeah, but what? The thing is, we're looking for the intersection between two sets. The first set is everything within radius 20 picoseconds. The second is everything that is far enough along the path that it saves time. We either need to look at everything in the first set and filter for those in the second, or we need to look at everything in the second set and filter for those in the first. Going for those in the first is O of 20 squared, which is still constant. Going for the second is O of n, but we are looping O of n times anyway, so this ends up being O of n squared. The other one is just O of big constant times n. Time to find the path is the same in both solutions. Like this step is not the inefficient part. It's the fact that it's O of n squared that must be inefficient, which is kind of unfortunate. But I guess it makes sense. Given that n is 10,000, I should have known that n squared would be too slow. Well, what's worse than premature optimization is unoptimization. It will be faster for smaller input, yes. Because it's O of path length squared, but the problem is the path length is O of n squared relative to the input's grid side length. How many blankies do you have now? You've learned something new, which is that optimizations don't always actually optimize, and it is important to actually consider the time complexity of your algorithms before you think that they will save any time. Well, what we have learned is that this was a waste of time, actually. 25 minutes. This is very unfortunate. All right, day 21. Day 21 is the keypad one where you had like 25 stacks of keypads where you needed to like keep inserting, what's it called? Having robots pushing robots pushing robots. I will go drink water actually. And I'm also gonna go use the washroom again. Y'all should stand up and stretch and drink water. See you in a bit. Enjoy the music. What if you didn't? Well, I'm not your mom. I can't tell you what to do. I would recommend it though. Anyway, enjoy the music. I have returned. I should figure out... I should, like, improve my streaming setup slightly. I'm currently fading the music in and out by just dragging the desktop audio volume slider by hand in OBS. To be fair, it works. All right. So, we're getting very close to the end of the stream. And what if you sorted the paths by what? What are you sorting the path by, though? I don't think that... I'm not sure that works. I don't know. I think it ends up being the case that searching for everything within 20 radius is better than searching for... Sort by distance? Distance from what, though? Because, like, you can't sort for distance from the current point, because that would be O of n log n, which would make your final solution n squared log n, which would be more inefficient. Like, unless you can pre-sort the entire thing in one go, but I'm not sure that works at all. It is an interesting thought. If something like that does work, that would be interesting. Yeah. Okay, looking at problem 21. I think this was an unpopular problem for a lot of people, but I personally quite enjoyed this. It's the one where you have a bunch of robots pushing other robots' buttons in a chain of length 25. And one interesting observation is that if you, for example, note that in this example, you can either go right, up, right, up, or up, right. But noting that if you do up, right, up, counter, thank you. If you do up, right, up, then the next robot needs to move its arm to the up button, then to the right button, then to the up button, which would increase its length, so on and so forth. And so it's never worth making more turns than necessary. And so the best way to get between 2 points is to just directly go up then right, or right then up, or whichever two directions. The only thing you need to watch out for is to get around the invalid space. So ultimately, this doesn't end up being enough of an optimization that I think it's worth really implementing a special case for. But let's take a look at it nonetheless, just to see if we can. Yeah, basically the way I am doing this is just brute forcing all of the possibilities. And I'm not convinced it really matters to... I'm not convinced it matters too much, but maybe it does. Let's see. No matter which two cells we are at, there is always a way to avoid the invalid cell. Notably, on this grid, if we are ever moving in the up right or down left direction, then we won't hit the invalid cell. And if we're moving in the up left down right direction, we just need to move right then down or up then left instead of vice versa. And similar thing for this one. Okay. I believe that we can actually simplify this a bit. I'm not sure it saves much time, but I think it makes the code a lot simpler. I'm not entirely sure, but let's find out together. And for those of you for whom it's very late, this stream will be done soon. I hope to finish within the next half an hour. We are in the last couple of problems, and several of these ended up actually being really easy despite being very late in the month. So like problem 25 is not worth revisiting, which is kind of sad, but this year's problem scaling was very weird. Okay. So compute sequences given a keypad takes each pair of cells and tells you the possibilities between them. However, because we need to go back to A each time, it actually doesn't end up mattering which sequence we pick. The idea behind having multiple sequences was that in case you needed to go from here to here and then from here to like here or whatever, or no, sorry. What was I thinking? In case you needed to go from here to here and then from here to here, it might save more time to not have to switch between going down and going right. So for example, this path might be faster than this path, but it doesn't end up mattering because in between here we need to press A, which requires us to take the subsequent robot's arm off of the A button anyway. So it doesn't actually end up mattering. And so what that means is that the optimal way to get between two cells can just be pre-computed, and we can just assume that it will be one specific thing. And so notably, if the keypad is the numeric one, then we just need to note which is more optimal for getting from A to there then back to A. But we also note that it actually does not matter. So if we go up left, that means we need to take one move here and then 2, 3, 4, 5, 6 to get back. But if we go left and up, it's 1, 2, 3, 4, 5, 6. So it ends up being the exact same no matter which order we press the buttons. And so it ends up not mattering at all. What this means is that we can pre-compute this a lot easier by basically just cutting out the entire search step, which is this step, removing all of the possibilities, and then just not really hard coding, but just finding directly where we want to go. So give me a second to construct this. The first thing we can notice is that sequences is currently a list of options, but we no longer need that to be a list because we no longer need to consider multiple possibilities. The number sequences thing is inserted into solve. Solve takes a list, a map from each pair to a list of options. We no longer need options. So we no longer need the Cartesian product, which means that we just need to return blank list.join sequences xy for xy in zip a plus string string. So if you don't quite remember what all of this does, please refer back to the video. But basically, by removing the possibilities from the sequences, we no longer need to take the Cartesian product to check every possible combination of the options. Instead, we just say that there is only one optimal option for each pair. So now that we have the x and y, which are the two things that we are trying to get between, we have two options. So if it's the numeric keypad, then that means the invalid spot is in the bottom left. If it's the direction keypad, that means the invalid spot is in the top left. So if the keypad is equal to the numeric keypad, then we'll do something, and otherwise we'll do something else. This ends up being a bit hard-codey, but it's okay because it's advent of code. You're not meant to... Advent of code, it's okay to hard-code stuff a bit more than usual, in my opinion. So, hold on a second. Yeah, so we want to get the row and column displacement. So the row displacement, or the displacement in row, which is positive if we're moving down and negative if we're moving up, is going to be, or I guess we should get Rx, Ry equals the position of X, and, Rx, Cx is the position of X, and Ry, Cy is the position of Y. And so the displacement in row is just Ry minus Rx, and the displacement in column is Cy minus Cx. So if it's the numeric keypad, then if we're moving up and to the, hold on. If we're moving up, then we want to move up first to avoid this cell. And if we're moving down, we want to move sideways first, also to avoid this cell. So basically, because let's suppose we're trying to get from 4 to 0. That counts as moving down. If we move down first, we'd hover over the invalid spot. So we want to move sideways first and then down. If we're moving up, then if we moved left first, we'd hover the invalid spot. So we want to move up first and then sideways. So if the change in row is greater than 0, that means that we are moving down, which means that we want to move sideways first. And so in order to move sideways, we can do something decently clever, at least in my opinion, which is that if you take a string and multiply it by a negative number, it doesn't error, it just gives you an empty string. And so what you can do is, let's say you have some arbitrary value x, which is either right or left. If you want to say left by x or right by x, what you can do is this, which says repeat the left arrow by negative x and the right arrow by positive x. What that means is if x is positive, only this applies. If x is negative, only this applies. And this avoids the need for an if statement. If you set x to -3, then this works as well, but with 3 left signs. Basically, whichever one is not the correct direction will be an empty string, and so will be idempotent when added. Or rather, identity when added. So, in order to move sideways first, we're going to do left times negative dc plus right times dc plus down times dr plus a. What this is saying is we're going to move left or right by whichever direction is appropriate times dc, and then we're going to make our downward movement to avoid the invalid cell, and then we're going to press A. If we're not moving down, then we're moving up or not moving our row, which means that we want to make the up movement first. And so we're going to make the up movement times negative dr, and then we're going to do the same thing again. And this is the point where I realized that there's something actually even more clever here. What I've realized is that basically we're saying the up movements need to come first, then the sideways movements can come in either order in between, and then the down movements need to come last. Which means that we can, because this is an empty string if dr is positive, it doesn't change anything if we add it here, correct? And because the downward movement depends on dr being positive, then if dr is negative, it doesn't change anything to add it here, which means that these two cases are actually the same thing. And so this ends up being all we need. We'll make our up movements, then our left-right movements, then our down movements. And if we're using the direction keypad, then in order to avoid hitting the top left invalid spot, we will make our down movements first. And so we'll just do down times dr plus left times negative dc plus right times dc plus up times negative dr plus a. And I think that works. Hello? Oh. Solve initially returned a list of possibilities, but we no longer have a list of possibilities. So I think because inputs is no longer a list, it's just total plus equals compute length inputs times int line colon -1. Or rather, instead of inputs, it's solve line number of sequences. No. Group debugging session, which number is it now? Oh, it's because I didn't paste the inputs. Yeah, okay. Fun fact, if you don't put any inputs into your program, you won't get the right answer. That is also extremely wrong. Well, this is moderately embarrassing. What is the problem here? Oh, because direction sequences is also no longer a list. So, right, this should be just length of value. And this is no longer a list of sequences. So instead of minimum of compute length, it's just length plus equals compute length direction sequences for x, y at depth -1, I think. That's a big number, but it's not the right big number. What? Okay, so the number is too large. Which makes me wonder if this solution is actually incorrect, which would be very unfortunate because this in theory seems perfectly valid. Okay, let's do a quick inspection of the pre-computed values. Okay, so let's see if these make sense. Let's pick a random one. To get from 6 to 1, what it is saying to do is to move left, then down, then hit A. That's correct. To move from 1 to 3, it says move right twice and then hit A. To go from 4 to 9, it says move up, then right, and then hit A. Yeah, those are all correct. Those are all very much so correct. To get from up to left, it says go down, then right, left, then hit A, which is correct. To go from left to A, it says right, up A. That is also correct. These all make sense. It does look kind of like that, yeah, which is very suspicious. .68 something. Okay, so it's not exactly double. Having a one-off error makes sense. Having a 2x error would be very strange. Let's see. if we get back the old code, and then if we get back the old code and print out each of the lengths, that might give us a bit of a hint. Okay, so it is the lengths that are all wrong. It's saying that it's meant to be longer. Did I miss something? There's no... None of the paths go out of bounds of the keypad. Let's inspect these functions. So this we determined seemed to output correct paths. What if I inspect the previous code? If I inspect the paths on this, for x in numseq, print x num sequences x, exit 0. Okay, so it's saying to get from A to 7, the best way is to go up 3 times, left twice A, up 3 times, left twice A, or up left A. Yeah, these all seem correct, except these are all going to be inefficient. I'm pretty sure we determined these will be inefficient except this one. So now, did this give us the wrong answer? To go from A to 7, it's up, left, A. Yeah, that seems correct to me. Very, very strange. Because I'm fairly certain we determined that it doesn't matter which arrow you press first. Like, if you need to go up and right, then... it shouldn't matter. Because there are only 2 possible ways that are fastest to get to a path, which is to go up then right, or to go right then up. And I'm fairly certain it does not matter which one we pick. So what do you mean left to up and right? Going from the left button on the keypad to the up button by going up and then right? Yes, that would be invalid because you would hover over the blank, which is not allowed. Surely it's not a one-off in the depth counter. That can't possibly be the problem. That is indeed not the problem. Okay. This is not a time save, right? Yeah, it's not a time save. Just trying to save complexity here, but it doesn't seem like this works for some reason. Let's see, the solve function takes a string that needs to be input, appends an A at the start, and then goes through pairwise and solves each, and gets each sequence between them. So for 341A, it says starting from A, we want to go up, hit A, up, left, left, hit A, down, hit A, right, right, down, hit A. Yeah, that seems correct. And now what if we solve that using the direction sequences? Left hit A, which would go up. Right hit A, which would hit A on 3. This doesn't seem problematic. Is there a way we can try this on part 1 to see if we can debug using that? Okay. Oh wait, part 1 and part 2 are the same thing, but you just changed the depth to 2. $68, $60, $68, $64, $64. Okay. So it's 379A that's problematic for some reason. Okay, so we've identified that the issue is the last... one of the issues that we can use for debugging is 379A. So that gives us this sequence. Is that one of these sequences that it says is valid? It doesn't specify. Okay. 029A is solved correctly. It says that it's left A, up A, right, up A, down, down, down A. And if we solve that again, we get this thing correctly. Yep, that works fine. And then if we solve that again, we get a correct answer. Yeah, so now what's the problem for 379A? Okay, so for 379A, it says to go up to the 3, hit it, go up, left, left to the A, go right, right to the A, and then down, down, down to the A. Yep, so what does this say we can do? Left, down, left to the A. Which would go left, down, left would give us that. It's the same as down, left, left A. That is fine. Let's compare. So up to this point, this is the same. These both go down 1 and left 2. and then hit A on the left button. These both... Okay, so this is one instance where it starts to diverge. So this sequence says down, left, A, which hits the left button, right, up A, which hits the A button, down A, which hits the right button, up A, which hits the A button, left down, which hits the down button, left A, which hits the left button, A, which hits the left button again, right, up, which hits the A button, and then A button again, down A hits right, left up hits the up arrow, right hits the A button, A again, down hits right, up hits A. In theory, I should make like a script that can reverse this step for me instead of doing this by hand, but I'm already here, so whatever. Okay, so that's the sequence that the optimal solution is saying that it can do, and mine is saying okay. So what is the difference between these two? I think this is still one layer ahead, so this should give us our final sequence, which is up, A, left, up, A, right, A, down, A. And this one is giving up, A, up, left, what? Up, A, up, left, A, right, A, down, A. That seems wrong. This is curious, because the only issue is that there seems to be an extra thing here. No, I must have mistranslated. I must have mistranslated the upper string. Up, A, left. Oh yeah, I did mistranslate it. A, right, A, down, A. Okay, so this is the only difference. Have I been wrong about it not mattering? Am I wrong that this doesn't matter? Because the difference is that this translates to okay, so left, up, A translates to down, left, AA, right, up, AA, right, A. And up, left, A translates to left, AA, down, left, A, right, up, A. Left, up goes from 3 to 7. So these are the same, but then when you translate these, the difference is that this becomes left, down, A, left, AA, right, up, AA, down, A, left, up, A, right, A, down A, up A. And this translates to down, left, left A, right, right, up A, down, left, right, right, up A, down A, left, up A, right, A. Okay, I see now. I think I finally get it. Switching the order of up and left, the issue is not stepping outside the keypad. The issue is that I was wrong that only one possibility matters. Because going left, left, up does not change the length of this next step immediately, but it does affect it in a way that changes the step after that. And I think the reason is because... What is the reason? I'm confused, kind of. Where are we losing? Where are we losing space? This has how many A's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, just making sure I didn't get it wrong. Yeah, I'm confused. Okay. So for reasons, going left then up versus going up then left is actually not the same, because the influence on the next step, even though it doesn't change the length immediately, can cause the step after it to become longer because of, I don't know, I guess just bad turns or something like that. Okay. So it's still in all situations suboptimal to switch between directions more than once, but this does mean that we have another case we need to consider, which is here I'm making my up before left, right before down, and assuming that that is the only option. But it seems like we also have to allow down before left, right before up. So I think so long as that doesn't step into the forbidden cell, it's valid. This is very, very annoying. I thought it wouldn't matter, but it does. The thing is, it never makes sense to switch more than once. It's just that starting down and then right is different from going right and then down. And I'm not smart enough to see exactly why or explain it in a way that's intuitive. But yeah, that seems to be the case. So we are assuming that we're going up first, then left, right, then down. But it seems that we're also allowed to go down first. So the only situation in which going down first is not allowed is if we're above the thing or if we're to the... Okay, so basically what's going on here is that this sequence here, up, then left, right, and then down, this ordering, works for all situations. So if we're going this way, it'll go like this or like this. And if we're going this way, it'll go like this or like this. However, the opposite face is also possible for a lot of situations, and it seems to matter if you add more than one iteration, which is very, very frustrating. The robot at the above level, yes, I think that is the issue. So let's rewind a bunch and pull the original code again. So I still do not need the search algorithm, but I now need to account for multiple possibilities. So I need to keep this accounting for multiple possibilities and this and also this. This is highly annoying. We need to have multiple possibilities still, but we can get rid of this. We no longer need to do the search. So this is still going to end up simplifying things. Even if it took us like an hour to do this problem, we still saved at least 2 lines of code, and that's worth it. So if the keypad is equal to the numerical keypad, then we're going to have that possibility of going, what was it, up, then sideways, then down. So up times negative hold on. Okay, since we don't need this as a map anymore, we can just make this a list of items. Pause.append RC keypad RC. Actually, no, we don't even need to do that. We just need to do pause.append RC if it's not none. Okay, so now we have a list of positions that we can say for RX CX in position, for RY CY in position. If it's equal, then we skip, but also notably X equals keypad at RX CX and Y equals the keypad at its position as well. And so if we can put this back, if X equals Y, the sequence is just to hit A directly. Otherwise, okay, this simplifies things a bit. So otherwise we get the row displacement as RY minus RX and the column displacement as CY minus CX. And now we can go up, then sideways, then down again. So up, then sideways, then down. And if it's not that keypad, then we can go down, then sideways, then up. But we also need to account for the possibility of being able to go down, then sideways, then up for the numeric keypad. And the same will apply for the direction keypad, which we will see in a bit. Basically, the only situation in which this option is not allowed is if one of them is in line, if both of them are in line with the null. So also of note, if we are vertically aligned, then going up, sideways, down is the same as going down, sideways, up, because two of them will be missing. If we are aligned horizontally, then that means that these two will be missing, which means that, again, it won't matter. And so the first condition we need to have is that dr is not equal to 0 and dc is not equal to 0. If dr or dc is equal to 0, that means that only one of these cases will exist, which means that it doesn't matter which order we pick. So firstly, we have to actually be moving in two different directions for it to matter for us to consider the other case. The other thing is that we cannot have it be the case where both of them are aligned with the invalid cell, because if they're both aligned with the invalid cell, then the other direction would make us collide with it. Note that this is why in this case I said it doesn't matter which way we go, because it's impossible for both of them to be aligned with the invalid one, because the invalid one's in the bottom left. And so if this one's aligned, this one can't be. And actually, this one just can't be at all, because the invalid cell is in the bottom left, and this one is both to the right and above it. So if one of them shares the x, if both of them share either their x or the y coordinate with it, then we must also not consider it. So first we need to check that hold on. So dr and dc must both be not 0, and we must have it be the case that either of them are not aligned. So it's two cases separated by or, where the first case is that x is not aligned, and the second case is that y is not aligned. One of them needs to not be aligned. So in order for x to not be aligned, it must share neither coordinate, which means that Rx is not the invalid position. This is getting very hard code-like. I apologize. Okay, since we're looking at the numeric keypad, the none position is in row 3, column 0. So either X is not aligned, which means that it must not be in row 3 and it must not be in row column 0. This here means that X is not aligned in either axis. If that is the case, then we don't need to worry about it. Or if Y is not aligned. So if this is not true, meaning that both of them are aligned along one coordinate to the invalid spot, that means one of two things. Either they're both aligned on the same axis, which means that this case would catch that anyway, or they're aligned on different axes, which means that going down and then right would hit the invalid space. If all three of these conditions are met, that is, first, they are not horizontally aligned, second, they are not vertically aligned, and third, they are not both aligned to the invalid space, that means that we can take the other direction as well, which is this thing. And I think at this point we can store these both as variables. I'll call this this one goes up, then left, right, then down. So we can call it up, sideways, down. And this one goes down, then sideways, then up, so we can call it DSU. So if we're using the numeric keypad, then we can always go up, sideways, down. And only if they're not aligned and not aligned to the invalid space, we can also go down, sideways, up. And now it follows without much reasoning that the same applies to the numeric or the directional keypad, but the other way around. We can always go down, sideways, up. And if the same condition applies, but with the new coordinates of 0, 0, then we can also go up, sideways, down. And this, theoretically speaking, should work. There we go. Finally, we have achieved the correct answer and saved four lines of code. Chat, we have successfully saved 4 lines of code by spending about 1.5 hours on this problem. To be fair, this code is also a bit more readable and a bit easier to understand. Like, what's easier to explain? This nonsense where we're doing a breadth first search for all possible optimal ways to reach it, or just logic? I think if we make this less hard-coded, this can be a bit easier to... I think this gets a bit easier to do if we don't hard-code it too much. We can store IR/IC as invalid. So if keypad RC is none, then IR/IC equals RC. Else position.append. And so now we can say... I'm trying to save more lines to justify all this time. So now if we find the invalid position dynamically, we get this, which technically unsaves a line of code, but it means that we're getting closer to being able to merge these two conditions together. So what we can then do is... This is not really code golf. This is more so trying to simplify the code. I'm using this to try to justify all the time we've spent on this. Technically, this is now redundant because this is no longer needed because dr and dc are both going to be equal to 0, which means that USD and DSU are both going to just be the letter A, and these conditions will prevent us from adding double. So now we've saved 6 lines of code. What else can we save here? We can say always equals USD if keypad equals numeric keypad else DSU, and then sometimes is the opposite. Basically what I'm saying here is that this logic is kind of the same, but we're swapping USD and DSU around. What I'm saying here is that if the keypad is numeric, then USD is always possible and DSU is only sometimes possible. If I'm using the numeric keypad, then DSU is always possible and USD is sometimes possible. I can also condense this by saying like always possible, sometimes possible equals USD DSU if the keypad is numpad, otherwise it's DSU USD. And so what I'm basically doing here is that the always possible and sometimes possible case for the numeric keypad is up, sideways, down is always, and down, sideways, up is only sometimes possible. And if we're on the directional keypad, then down, sideways, up is always possible, and up, sideways, down is sometimes possible. So then what I can do is I can avoid doing this if-else statement, which has a lot of duplicated code. I can say sequences x, y equals always possible. And if this condition is true, then we can add the sometimes possible case. And that doesn't even work. Lovely. Because there we go. Now our code savings is down to 10 lines. I think. Yeah, we're down to 10 lines of code saved, chat. Yeah, I missed the append because I am slightly blind. All right, surely there is more to save here, right? No, I think we might actually be at the limit of what we can save now. I think it probably doesn't make sense to try to save more. I don't think we'll really be able to. One thing you can do is you can move this into the outer loop. That doesn't really accomplish anything, but you can do that if you want. Okay. I believe this is the bound of what we can reasonably save. You can save line 27 by converting it into a single line. Okay, but that would be kind of cheating because I'm trying to save code using the new method. Looking for other savings elsewhere is kind of cheating. But yeah, I think that is the best we can do. But hey, this code is certainly a lot simpler than the other code. That's for sure. Now, did it take us way too long to figure that out? Yes, but whatever. If it works, it works. Okay. Well, I think we're getting close to the end of the stream. Let's wrap up. So, that was day 21. Day 22 is the Monkey Stock Exchange. There was nothing really to mention here, nothing to really optimize here. Day 23 is the LAN party. This one's a textbook graph theory problem, like literally textbook. It's just max clique. Again, nothing to look at there. Day 24 is the only other one that's really like notably interesting. Sorry, day 23, there is one errata that I do want to mention in my video. I said that symmetric difference is the intersection of the set difference A minus B and the set difference B minus A. It's actually the union. The intersection would obviously be empty. Right, counter. So thank you to Hyro and Michael Balsarek 4442 for pointing out this error. Also, thank you to Rubenberg for pointing out that symmetric difference is the delta symbol. I forgot about that. So, yeah, what I said was that it's equal to the intersection of the set differences. But since this set doesn't contain anything in B and this set doesn't contain anything in A by definition of set subtraction, if we took the intersection, then it would contain literally nothing. So that obviously does not make any sense. It's actually the union, and the symbol for symmetric set difference is the upward triangle symbol. So thank you to those who were named. That's day 23. Day 24 is the only other one that could be potentially interesting, but I think I covered this reasonably well. The only other thing we could really look to optimize here is to try to find a smarter way to do this than test every possible swap. So as a reminder, this is the problem where we're supposed to try to fix 4 swapped gate outputs to make our logic, our circuit a binary adder, like a binary addition calculator. And like I mentioned in the video, there's a way to do this by hand, and I did make a code solution that works by brute forcing all of the possible swaps 4 times. You could theoretically write a more efficient solution that looks for the point of failure, determines what failed, and then diagnoses it sort of like the way I did it by hand. But I will leave that as an exercise to the reader. The reason for that is threefold. A, I think the spirit of this problem is to do it by hand and have it be like a reverse engineering problem. You're supposed to figure out the structure of the system and derive the intended structuring and try to look for the incorrect gates by hand. The second is that I already have a generic code solution that does work. This would just save a bit of time and make it a bit faster and less clunky, but also make it depend more on the structure. The way I currently have it done, it actually works perfectly fine in terms of finding the first bit that fails and then testing every possible swap. This way it doesn't depend on the circuit having a certain intended structure, which technically is part of the reverse engineering and not part of the problem statement. The third is that the stream has been going for 5 hours, and I don't really feel like doing this because tackling this will probably take about an hour. So I think all of us could use some rest at this point, and that therefore brings us to day 25, a problem that was pretty trivial and didn't really cook ChatGPT, but did somehow manage to get me on the leaderboard for the last day. I somehow managed to get on the global leaderboard, so I'll take it. As usual, part 2 was just click the button, and so let's click the button again together. If anyone has any more questions, I noticed that viewership has basically vanished. But if anyone does have any more questions, please feel free to ask in chat. I will stick around for a bit longer. But that aside, that brings us to the end of 2024. Thank you all for watching. As for what's to come next, there are a couple of things that would be interesting to look at. Like I mentioned earlier, Code Golf is something that I might go back to explore a bit more. That's kind of where I got into coding and where I started building up an online presence in the first place. So it would be nice to revisit kind of like my origins. Coding tutorials would also be potentially useful. Like the funny guy or whatever he called himself said, um, there's really not too much to lose from looking into doing coding uh, tutorials. And yes, thank you, Pat. Everybody Codes is another annual event that would be very interesting to look into. I do not know when this opens. I know that the 2024 event is already closed, but it might be interesting to go through this again. To go through this afterwards. It's a very similar challenge to Advent of Code. There are 20 quests, each with 3 parts. It's in November? Okay, cool. But yeah. In the meantime, though, I might go through the 2024 one in the remaining months in this year. Potentially look through coding tutorials, code golf stuff. There is also, of course, the possibility that I end up uploading absolutely nothing until December 1st, 2025. I'm not going to say that that's not possible. That happens sometimes. And by sometimes, I mean every year so far. But I don't know. Maybe 2025 will be different. Yes, Pat, you should push me because I think people for some reason like my content. I don't know why, but they do. From Capitan Toinol. Hey, not a question. Just want to say I followed AOC 2024 every day alongside your videos, and you saved my ass a couple of days. It was really fun watching along. So thanks for the content. Glad to hear. Thank you for tuning in, and thanks for watching. New Year's resolution. Yes. I don't want to make it a New Year's resolution because that basically guarantees that it will be doomed to fail. You know how New Year's resolutions tend to be. Theme. Potentially. Well, why everyone uses Python? Because Python is just great for these challenges where the problems are not algorithmically complex, are not too algorithmically complex, and where writing the code fast matters. Python has a lot of nice features like supporting a lot of nice list utilities, having quite easy to access regex, having infinite precision integers, all sorts of stuff that makes it just very nice for this specific class of problems. Also, its syntax is simple. I do not like Python for big projects, but I like Python for scripts, which is kind of exactly what the point is. Also, Satya, I am sort of looking for a job, so I might take you up on that offer. Do I have you on Discord? Can I fix the leaderboard for AOC next time? That is something else that I also might look into. Yeah, so of course, as you all know, the whole AI issue was a pretty big issue for the leaderboard this year. I highly doubt there's anything that'll really improve next year. I might get in touch with Eric again. We'll see about that. I also might just set up my own system for it. Maybe make my own like competition ID or something that some people have mentioned. Maybe have like a private leaderboard that requires like video verification or something like that. Satya, do you? We could use LinkedIn. I'm not a huge fan because my LinkedIn account is still using my dead name and has a lot of personal stuff attached to it. Uh, would email work for you? Um, I can give you my email address because it is. I do have a public business email. If you send me an email from there, then I can privately obtain your email. Only if you're okay with that, though. Um, sure. Yeah, I'll send it in the chat. It's just hyperneutrino15@gmail.com. Um, I can explain why it's 50. I can explain why it's 15 if anyone's interested. But yeah, obviously the global leaderboard can't really rely on stuff like forcing people to be able to record or stream. But a private leaderboard could do that. Maybe we could do something around that. I'm not sure yet. What other questions? Someone asks, what is this? Any type of competition? This is the Advent of Code, which is an annual challenge through the month of December. Each day at midnight in Eastern Standard Time, a two-part problem is released. The problems are not like usual coding contests where you have to upload your code. Instead, you just need to obtain the answer for your input in any way possible, including mixing languages, hand solving parts of it, etc. Once you solve part 1, you unlock part 2, and the first 100 people get points ranging from 100 to 1 depending on how fast they do it. First time here, you only do coding, right? Yes, I only do coding. The only non-coding related videos that I really upload are like the 2 or 3 trends related ones that I've uploaded. But I rarely upload stuff like that because this is a coding channel. So yes, I really only do coding. I've considered making a secondary channel for other things like music, video gaming, or whatever, or just putting that directly on my main channel. But I don't think people would be particularly interested, so I haven't actually really considered that much. Would love an EU leaderboard. That could be cool, although verifying that people actually did it at the same time is going to be difficult. I don't know exactly how you'd prove that. I might consider making a second channel and just throw stuff on there that I don't really put any effort into. That could be interesting. If I do that, you will hear about it, of course. As for where the hyperneutrino name came from, that is an excellent question, and I'm not honestly sure I know how to answer that. The neutrino part came from a phase in my life when I was particularly interested in particle physics. That didn't end up really going anywhere. I was briefly considering applying for physics for university as a second, a backup option for in case I didn't get into CS. But A, I did get into CS, and B, after talking to some people in physics, it seemed like it was probably a bit beyond what I was capable of, and also not necessarily the direction that I was interested in going in. But I was interested in casually learning some physics stuff, so that's where the neutrino part came from. As for the hyper part came from, I have no idea. But it's funny because the hyper part is what most people call me now. There was a period of time where most people abbreviated my name to HN or neutrino, but nowadays most people shorten my name to hyper instead, which makes more sense, in my opinion. As for why 15, it's because when I was in middle school, I competed with a couple of friends in an Ontario provincial robotics competition and got first place with my team, and our team number was 15. You can ditch one letter and call me Iris. This is true. You can also ditch one of those letters and call me the IRS. I'm here to collect your taxes. All right, thanks, Satya. Yeah, I will get in touch with you if I'm not having great luck with job search, and once I really decided what exactly I plan to do in the future. We'll see. But yeah, this was a fun stream. Uh, Hope it wasn't too boring or prolonged for y'all. Next year, I'll probably try to go back to breaking it down into multiple streams, like week by week. I think that would probably be a bit more digestible than a 5 hour stream going through all of the problems. Uh, Also, I'm sure that like taking a long time to figure things out closer to the end has something to do with fatigue, but we'll see. This year I just kind of got lazy and didn't get around to doing it, but you know, we'll see how things go. Also, I made a whole technical difficulty screen for the stream, but I didn't end up actually needing it, but you know, may as well. In any case, yeah, seems like that's it for the stream. If you have any questions, feel free to ping me in my Discord server. It's linked on my YouTube channel. Pat, I already set the thumbnail to Advent of Code 2024 Revisited. But yeah, thank you all for tuning in. If you think of anything last second and want to mention it, I will stick around in the text chat for a bit. But in the meantime, I'm going to start taking down my streaming setup, and you can enjoy the video, enjoy the music. Thank you all for tuning in.